Recording started, and then we'll load up where we were yesterday, and you should have something along these lines. And we should see how we go about doing this. Now, when you're running field to finish, the other thing to keep in mind is that you don't have to do what we're doing here every time you do this, because hopefully, you're going to have your code table set for almost all of your potential types of observations. Then you just come in and run it, and it generates what you need, and off you go. So, but if we look at, for instance, if I select this point, remember our defaults for points. If we just draw locate points, our defaults are going to go on, this layer that we designate here. Typically, just by default, it's P and TS. But if I look at, say, this one's for the pavement, because we had this code that generated this line work here. See, it's on a layer up here in my properties called C Pave PK lot. And this one, for instance, is on points, so we didn't change that one. This one is on also points. This one is on a layer called 24D. There's one called 8P. There's one called IP. EOP is a layer for edge of pavement. And then out here, the piece of text, because that's on there, but that's on a layer called spot for spot elevation. And up here, let's see, that's the fence and the monument. Yeah, V site node. That's how we change that layer for fence. And we got this new line style to go with it, which is set to be a particular line type that we chose. We could have said to use by layer, as long as when we put it on this layer, V-site fence, the layer is defined to have a particular line style, but you see, it's not. It's on it's just assigned continuous. Now we do have a layer called fence, and it's got this line style defined. So we could have made our code go with that layer and choose that particular line style to be by layer. Right, let me take a look at, say, by layer, and it's on that V-site fence. But if I change that to fence, so that uses even a different line style. That was the defined line style for layer fence. Okay. So let's go back to our survey menu and choose draw field to finish, and take a look at some of these settings a little more deeply. In the dialog box at the top, you've got, again, you can set a particular range of points. So if you've got, several hundred points, but you're working on a trouble spot and you're working on some codes down there and just changing those points, you don't have to redraw the whole thing over and over again. You can restrict that to just a certain amount of points, or you can choose a point group, in which case I've got, there's the one that we used when we imported. We can set our field to finish codes to create and assign a point group based on the codes. And if we look down here at our additional draw options, that's this button down about midway down the dialog, you can see in this, about a little below the halfway spot down the dialog box, there's a little group that says creating point groups. And you can say automatically by code, And if we do that, it's going to read the codes that it sees in our coordinate file, and it's going to create a point group for those defined codes. Or you can also do it by code definition. So if our code was FNC for fence or whatever, it's FL for fence line, I think we used, then it would generate a code with the way I have mine set right now. It would generate a group called FL, and all of the FL points would go into that point group. But my code definition, my code FL could say, put this in a group called site, site options, or um, barbed wire fences or whatever. You could have a different group based on the code itself, or simply create a group that is the code name itself. Okay. So if we have those set there, and you can also put a group name prefix. And this is useful sometimes is if you're going to run this based on, say, different days worth of coordinates in a different coordinate files, you could put in, say, today's date or the party crew or whatever else that you want. And it's just a way to help you manage your points into some manageable groups. Okay. And then you've got, all of these notes and things that you can create. You can keep layers frozen. If something goes on a layer that you have normally frozen, if you don't have that checked, when you run field to finish and the code says put it on a layer and that layer is frozen, it will thaw that layer to show you that it put it there. Otherwise, you can leave that checked on and it will go ahead and put it there, but it will keep the layer frozen so you don't see it when you finish. Let's see. Set levels by codes, pause on undefined codes. Right there, this pause on undefined. If you do that, it's going to run and then it hits a code that it doesn't have in the library, and it's going to pause the operation and give you a message. Otherwise, it's going to just dump the point in, wherever it goes, just on the generic defaults on that layer PNTS and the default symbol, etc. Okay. Now, up here above, a couple of things. You can see these check boxes appear pretty self-explanatory. And then what I would make sure that you have set is you want your points to go on the real z-axis. That means it's going to plot them at their elevation. It's not necessary, but I like to do that and just as a general practice anyway, so I can see where they are in 3D space. And I say it's not necessary because a Carlson point with elevation, if you don't plot it at its elevation, it plots it down at 0, but it still reads the elevation out of that information when it needs to look at those points, like when it's trying to model terrain, or if it's trying to draw 3D lines and you're going from point number to point number to point number and they have elevations, then it reads the elevation out of the point. It doesn't read it out of the graphic on the screen. So you don't have to put those where they go. You can leave them all at 0 if that's your preference. I like to have them there myself. That's the way I have mine set for on. And then locate line work on the real Z. I say by code, meaning when the code says to draw a 2D polyline, it's going to always be done at 0. If I say to draw a 3D polyline, it's going to put the 3D polyline at the elevation of the points it's drawing between. And if I say off, then or if I say on instead of by code, then the 2D lines, I believe, are set at an elevation of the first point. as a constant elevation. I'm not sure if that's correct or not. It might always just put them at zero, but I think that's the case. So regardless, by code, keeps the 2Ds at zero and the 3Ds at their proper elevation. Now, the PCPT curve type and adjust PCPT for arcs to be tangential. What that means is this. When we see a code, and we'll talk about this PCPT code bit in a little bit when we get into the code definitions. That's a special code that says whatever you're observing, let's call it the EP for the edge of pavement. When you get to the start of a curve on that pavement, you're going to still call the code, the point that you shoot in the data collector, you're going to put in the description as EP, and then you'll say space PC to start the curve. Now, if you do nothing else, as you get the next 3 points along the EP feature, it's going to go to the second point and considers that a point on the curve, and it goes to the third point, and that becomes the PT. So it takes 3 points to define the curve. So starting with the PC, it goes to the third point and says, okay, there's the end of my curve. Right? And that's it by definition, is how it works with without using the PT code. However, and I, again, am a big proponent of start and stop codes and PC and PT codes, even if the default will do it without, I like to go ahead and do that as a best practice, just so that you're in the discipline of doing that when you're collecting the points. But it also gives the ability that if you have a PT code, you have a PC code, and then you can have any number of points along the arc. So maybe it's a very large arc, or maybe it's an S-shaped curve. It's got reverse curves going through it, etc. So you can shoot these points along the curve. You just start one that says PC. The next point you get, you just put the code of its description, like EP, then EP, then EP, then EP, then EP. And now when you're at the end of the curve, you say PT, you say EP space PT, meaning stop the curve. So you got the start, you got the stop, and all the points in between. Now, what kind of curve do you generate? And there's 3 choices. One is a Bezier curve, in which it does a sort of a smoothing through the series of points, but honoring each of those points that you observe. The one that's default says use sequential arcs. And the Bezier curve, by the way, is a non-circular arc. It's just like a smooth, weighted, smooth line with the points you observe being control points that the curve still goes through those points. Sequential arcs is going to always group them in pairs of 3, or in groups of 3 to form, the first arc, and then from the end of the first arc, taking the next 2 points, that makes those 3 points, that's an arc. Go to the end of that arc, and the next 2 points, that becomes an arc, until you hit the PT. So that's a way to get some compound curves in, but everything that's generated is a true circular arc. And then finally, the last choice is a best fit. And that will leave you with a true arc, but as you're getting points along that feature, it looks at all those points and does a least squares best fit that go through all those points, so they don't necessarily, they won't necessarily be on the resulting arc. The resulting arc is a best fit through those points, but not guaranteed to go through all the points. You follow what I mean? Okay. So sequential arcs is the default, and it's what's most commonly done. And just to be aware, so that you're aware of how this is going to process. It's going to take those groups of 3 points to make true tangent arcs. And when I talk about arcs and tangents here, I'm talking about a 2D line work that comes out of this code definition. But as it's creating, or if it's creating, like in the case of of an edge of pavement feature or any kind of feature that we need to generate 3D lines for, also, then it's going to generate the 3D, just like we saw yesterday with that little maximum offset conversion by all those little segmented pieces. So that part gets done regardless, but it's these arc fits, and those aren't true arcs. Those are little segmented pieces to define it as 3D as it goes up and down the elevation. Okay. So when we're talking about these, excuse me, these tangentials, we're speaking of the 2D component of that. And so then finally, there's a checkbox that says adjust the PCPT to make sure the arcs are tangential to like the incoming tangent and the outgoing tangent, and you give it a tolerance, which is probably a little too much. I'll maybe cut that down to 1/2 foot. And what that means is if you go up and you hit EP, EP, then you start a curve, you go EP, PC, and then you do another EP and an EP, PT, and then you go on, you get another point on the tangent to define the outgoing tangent, so EP. So I've got an incoming tangent, I start the curve, I end the curve, I've got an outgoing tangent. But if the curve points that I shoot, okay, between the PC and the PT, any points between those that are on the arc, it's going to make a circular arc. But as you can imagine, it's not necessarily going to make that tangent to the incoming tangent and the outgoing tangent. But if you have that checkbox on, it's going to shift the resulting drawn line work start point of that arc. It's going to slide it back and forth down that length of that tangent in either direction so that it finds the point where it then becomes tangent to those incoming and outgoing line work segments. Okay. Something not necessarily required, and it doesn't always work. So if it's outside of that tolerance, it won't move that resulting vertex in the polylines. But it also, if you're just shooting some site work and you want things to, that you can put your dimensions on in your finished work, then that's going to help maintain those as tangents, and then you can label those arc pieces, etc., with true dimensions, and they're going to be you're going to keep your geometry being tangent. Okay. When it comes down here, this bottom section, this little checkbox here that says allow 3D arcs, that's a little bit of a misnomer. There is no such thing as a 3D arc, and it won't generate 3D arcs. It will always generate those individual chorded line segments as it makes 3D polylines. What that means, it should say allow arcs at elevation. It's still a 2D arc, but it's going to set it at the actual point elevation that it's starting from. So instead of forcing it down to 0, it will allow it, if a code says to use it, it will put it up at a particular elevation, but it's still a constant elevation. That's what it means by 3D, is that it uses elevation. Okay, so that's basically, again, like I said, some sort of set and forget kind of stuff. The one thing you might adjust is this arc behavior on how the curves get generated, depending on the type of surveying you're doing at any given time. But that's where those are done in this additional draw options. And then you do like erase the existing field to finish. So if I make some adjustments and rerun it, It's going to erase what was done before and redraw it. That's typically what we want. And we say erase in range. So up here at the top, if you've changed the group of points that you're plotting, it leaves the others alone, but only erases the things that are going to be redrawn. If you say preview only, it's a bit wasted. That's sort of, it's going to generate what it's going to look like and show it to you. But as soon as you zoom in or try to pan the screen, they go away. They're just temporary graphics. And there's no real reason not to go ahead and draw them and have it erase them and redraw it if it needs to later. Um, I don't know why they really give you that option. It's just kind of useless because as soon as you want to zoom in to look at something, it's gone. You got to run it again, right? Fixing overlaps, you can do that, and it tries to rearrange the point attributes so that they do not overlap other point attributes. It will slide them around a little bit until they don't overlap. It takes a little bit of time in processing, so I usually leave it off. And then you can also triangulate and contour. If you turn that on and hit your setup and define uh, the output file and everything, it can actually, as part of field to finish, go right straight into finalizing everything and generating the surface all in one step. And I generally don't do that. I like to see what my data looks like before I do that process, and I run that as a separate command. Either way, your preference. And then again, we've got the code table. Our coordinate file is the one we have open and assigned anyway, but you can switch to a different one. And same thing, switch it to a different code table. Now, keep your eye on that. If you notice right here, mine still says SHTZ codes. I don't know why that is there. Let me double check something here. Yeah, see, that's only got the 3 codes that we should have set. This data set to this F2F example. It should have stayed there from yesterday. I don't know why it didn't. I'll keep an eye on that to see. But keep your eye on that and make sure, because if you go to the next job, it should hold the value from the last time you run it. So you may have to switch it if you're using a different code table for a different job. Okay. And then you've got this report codes and points. And that was the very same thing we saw yesterday from inside the code editor down in the bottom corner, that we were able to see those points that say don't have codes. So we just run that again. So only report undefined. So now I've got 0 points with undefined codes because we went to our edit codes button and we ran this down here in the bottom left corner. We said, do a code table by points. And what that will do is it will read the point file that we're using, this F2F example. No, I'm sorry, F2F-test.crd, and read all of the descriptions in that coordinate file, and it will create a code for every one of those that it sees, and it will add it to whatever you've already got defined. Okay, so that was where we saw that FL, and we were able to put, let's find there's our FL. And this is where we edited this yesterday, and we started talking about what layers to put things on. And in this case, it's drawing 2D only. And we go to line type, and that was where we made it a particular line type. I'm going to set that back from that one and just set it to by layer. But I'm also going to hit edit. I got out of the edit. I'm going to change this layer now to put this main layer, I'm going to set that to be layer fenced, because that's over here where I did it up here that had that predefined line type. And instead of the one I had. So when it draws it on that layer, it's going to use that line type that was predefined on the layer itself. Okay. Color is set to by layer. A distinct point layer means the points that get drawn are going to go in its own separate layer potentially. And this is where any line work that you defined in the code will get placed. Okay. Again, fences and walls. The attribute format is whether you're using the attribute block, which is the point number, elevation, and description, or whether you're using text as opposed to that. Or you can use them both, or have none, so it suppresses all of it and it just draws line work. Okay, and then if you choose, there's this button on the side to set up these labels, and we're not going to go in deep on this, but you can generate not just the point number, elevation, and description, but the northing, easting, and all of this information as well. You can put little prefixes, assign them to different layers over here, and different text styles and how they get done, as well as GIS attributes. If you're collecting GIS data along with your field point information, they can read all that stuff and generate that and put it in the drawing for you. All right, so I'm going to cancel that. We don't have time to get into all of that stuff. But that's something you can explore as you get a little further into this. Separate attribute layers now will put your points on a particular layer that we've already set up here, this distinct point layer. But then you can also put your symbols on a different layer itself. So if I say symbols, you say set, then it's going to put the attributes on this layer, whatever you decide, and then the point number, elevation, and description, those are your attributes. And notice it takes that same layer name. Now you can make these anything you want, but by default, it takes that layer name and puts an NO, an ELEV, and a DESC, and an MARK as separate layers for those particular attributes, okay? As opposed to having the points going just on this layer called vSite node. Okay, so I'm gonna actually say none, and we'll keep those together. Your attribute layout ID, there's again that 1 through 0 through 9, there's a preview, and these were those, there's your default of number 1. Here's your number 3, for instance. So that's going to be how that behaves. And here's where this code definition for point groups, and we can set it to a particular one that we may already have defined, or we can go ahead and define this one. And remember, we've set our options to create a point group based on the code. So it will put it in a group called FL, but the code says that FL, we're going to also define this to be a group called, just call it site elements, okay? A little broad in category, didn't really help us, but I'll just show you how it generates that, okay? And then here are our scalar, our plotted inches for our attributes, okay? Different if you want to restrict the elevation integers, the integer part left of the decimal place. If you want to restrict that, and then how many decimals after that you want to display, regardless of what your units are set to display, it can truncate those for you. Okay, you locate these on the real z-axis. Thanks. Okay, so that's gonna be lovely. I just had a lovely cup of tea brought to me. Wonderful. Okay, so Again, here's where you can do some other controls, and there's this little checkbox right here for non-surface. So what that does is controls whether the point itself will be used to generate, to help you when you're creating your surface. If it's unchecked, it will read the elevation of the point and use it. Now, these points on the fence line, for instance, are going to be shot down at the ground, and they're going to be valid points for the ones we shoot, but we're not going to get every point along the fence line that goes up and down. So the fence line itself will not be 3D, it's only 2D. That's where you see over here to the left of that, but the point will be red. However, if you do something like a fire hydrant code and you shoot the top nut on the hydrant and you don't want that to be used in your terrain modeling, but you still want the point to be in 3D space, then you would tell it to be non-surface and it will ignore it. Okay. And finally down here is this feature type. By default, and most often, it's going to always be a topo type of feature, meaning it's going to be there for generating what surveyors call topo. It's not really the right term, but that's what they mean by that. It's going to be a planimetric type of feature. When you go out and do a topo map, we're talking about doing a planimetric map. A topo map technically is a topographic map, and it's to generate contours and elevations. But surveyors call going out and doing a topo, meaning they're just locating things on a map, and it's possibly with contours and possibly without. But that's what that means, is a planimetric feature. And then you've got three other special types. You've got trees, pipes, and utilities. Okay. And that sets up a whole different set of controls that you can use when you're out there surveying these types of things. And that's what these manuals here are starting are going to show you. It's got some tree codes and different things, where you're setting. Well, anyway, we'll see that when we get back to it. But there's some additional different things in there. Then you've got some, companion codes that go along with this. These are other code that connect line work with this current code. Okay, and you can have multiple codes. So let's say if I've got a fence line here, but I've also got, it's not a good example. I'm trying to think of an example that would use it. Maybe I've got another point that says, oh, trying to get an example. Anyway, it's another code out of our list of codes back here, the total list that says also connect to this code with its line work. Instead of just looking for FL codes, it can also connect these other companion codes. Okay. And any of these things that you get on here, that you're seeing and trying to figure out as you start to learn to use this, look at this help system. Okay, you always hit that help button. This is one of the largest of the help entries in the software. And it steps you through almost every possible example and explains what's going on, because it's really, it's like here's, there's a code called a ramp that actually generates all of this stuff in 3D space based on just a few things. Like here's the code would be a BC, back of curb, but that's going to be a ramp, 3, 2, and 1. Then well, that's the bottom of curb, not back of curb. I would have called that FC for face of curb, but anyway. So the special code has a 3 for the width, so it will generate the width 3 feet back, 2, or I'm sorry, for the 3 feet across, and then 2 for the depth and 1 for the side taper. So it's going to take a 1 foot taper on the sides. It's going to be 3 feet across the face of it, and it's going to be 2 feet back into the depth of the sidewalk. All that with just this code right here, okay? You don't have to go and shoot each one of those corners as long as it's a regular type of feature. Obviously, if you need those because maybe the sidewalk wasn't created, very uniformly, then you would not necessarily use that. You could use individual points and create those separately. It's just some helper codes, okay? So, it shows you how all of these different things are going to be used, different examples. Here's a great example of this thing called code sequencing, whereas let's say you're out shooting across, you're shooting cross sections across a road feature. Here's a shoulder, edge of pavement, center line, edge of pavement, shoulder, and it can be other things. It doesn't have to reflect the same left and right. It can be a shoulder and a ditch and an edge of pavement, center line, edge of pavement, a curb, a fence, whatever. And then you define all of those different codes already in your library as to the type of line stuff it's going to create. And then you're going to say, well, I'm going to shoot this, and you see the point numbers, that's the order. Go 101, 2, 3, 4, 5, and then go down to the next station, and there's 106, 107, 108, 109, 110. So I'll keep crossing. But if I do this without doing this as a sequence, when I'm out there in the field, I have to type in my description each time, SHD, EP, CL, then EP, then SHD. Then I come down here, okay, SHD stays the same. I can use that again, but then I have to remember to switch to EP, to CL, to EP, to SHD. Well, that gets to be a little tedious. So if I set this up as a sequence, I'm saying when I run this code, and the example they show you in here, right, I'm going to use a code called RD for road, okay? And I'm going to define my code RD to be this sequence of codes. I'm going to do shoulder to an EP, shoulder to an EP to a CL to an EP to a shoulder. So that's what you see right up here. And again, it doesn't have to be the same on either side. And that's the order in which I shoot it. And that's how I'm going to create that in my data set. So it's going to generate all of these little extra descriptions and tie all those things together for me. Okay. Now they've got the picture wrong here, because if you look at the order that this is done in, 101, 2, 3, 4, and 5, then they go up here and they go 6, 7, 8, 9, 10. So they go back and forth across the road. They should have this little checkbox in the lower left here that says Zorro style. That should be checked to match this. Okay. Otherwise, it would be, if that's unchecked, when you shoot this in the field, you've got to do it across this direction. Then you go back on the other side of the street and you do it back in that direction, go back on the other side of the street and you do it in that forward direction again. You keep doing them all in the same direction. This looks like it might work because it's the same. It goes shoulder, EP, and then center line, and then it's EP and shoulder. So when you start on the next one, it goes shoulder, EP, center line, EP, shoulder. It's the same because it's reflective, but it's not. It won't work that way. If you don't have that Zorro style checked, it will try to take this shoulder and connect it. That's number 106, and connect it to the 101. So it would go 101 to 106 to 111 when it draws the lines. And that's not what we want. We want the lines to draw along the feature that we are defining. Okay, so just take note of that little bit of help system is slightly off. But again, the whole point of showing you all of this is extensive in this help system. It's almost a book by itself, okay? But there's really great examples of what these different codes will do. And so we're not going to get a chance to explore that in all of its entirety. In fact, I'm still learning a lot of it from day to day myself, but it's really, really a powerful system. Okay, so keep that handy when you're working on things. That little help button, there's one here, and that was just for companion codes. There's one here that also just dumps you into this, as you're working on stuff. So, try to find those things out. All right, now. So we've defined our fence line and we've set it to this layer called fence. We've used it on a layer called, or with a line style that's defined on the layer. So there's that one. Now, one of the things I noticed was down here in this spot elevation, it generated text and it put the text at the decimal point of the elevation is right where the point is. And that's used to just make a spot elevation on the mapping. Well, I don't particularly care for that particular one. So I'm going to actually find that, which would be ground features in this thing called X. I'm going to change that definition. And instead of using that in that particular text attribute, so right there's the text attribute, and the GIS node point attribute labels button to the right of it says use the elevation. Okay. And there's its text. There's the layer. It's going to go on P&T TXT. Well, I actually might want to put that on a V site. What would we typically call that one? We're going to call that one V topo, topography, and then spot. We'll put that. It will create the layer for me. I don't have it created yet. It will put it there for me. I'll use my text. In this case, it would be standard. That's fine. Down here at the bottom, it says elevation labeled decimal on the point. I'm going to uncheck that. So it's going to go beside it, but I'm going to then draw my point to be the indicator for that spot. And let's see, what else might I want to do? It's going to be the lower right. So if I got the point, I'm going to put it as the upper right. See where it places it there. I may have to do an offset scalars above and below. That's like a full inch. It's a bit much. Let's just say 0.1, 0.1. All the way around. See what happens when we do this. We won't spend all our time trying to finesse that, but just so you can see what happens. So that'll work. So that when it creates the point, it's not going to show you the point number, elevation, and description. It's going to read the elevation, create the text, and put the text in the drawing, but suppress these other things for us. Okay. I did want to rotate that, but I don't see, oh, rotation right here. We'll go 45 degrees. See what that does for us. And the attribute format is here. Label dash dash points. So it's going to be a separate label if I want to turn the point itself on and off. Layouts, IDs two, point groups, topo. You don't have to have that, but that's going to show you what it's going to work. And let's then look at the symbol. And there's that point. It's going to be an X. That's exactly what I would tend to show. Line type doesn't matter because I'm not drawing lines, I'm drawing points only. All right, so let's see what that will do for us on that. So you're going to see some change to that one. for the spot, and we've got a couple of others to change here. We've got these codes, like the 18D oak, and the 8P, that's an 8-inch pine. We've got a manhole, different things that we can fix while we're here. Let me go to my utilities, and I don't see manhole in there. Maybe it's in on the side. Nope. Let's see, manhole. I'll click the code title at the top so it sorts it alphabetically. There's my manhole. I'll edit that, and it is in a category called trees. Well, that's stupid. That's because it generated that when it read the point file, and that was just the default. So I'm going to make sure that that gets put in its right category under utilities. It's an MH. It's got a description here, meaning it's going to plot that as the description in the drawing. If you wanted, you could even have it spell out manhole, or let's call it something separate. Maybe there's a sand manhole. That's going to be the drawing description, even though the points are still only going to have MH in the coordinate file. And our main layer, we'll say, is going to be, do I have a V site utilities? I do not. There's power, ditch building. It's like fence and node. So I'm going to put this main layer here instead of MH. I'm going to call it V dash site, or not site rather, util dash san for sanitary or sewer or whatever you want to put. Just as an example. Right now, points only. You go to symbol. I'm going to choose that symbol. I'm going to pull down this category and choose inlets and manholes. And oops, let's see what we've got. There's, let's say, use this. We'll call it a sewer manhole, assuming that's what that is. And you can make it a little bigger. Let's make that, say, 0.15, just so they show up nicely. And we'll say, okay. Now, that is also, by the way, I'm going to go back to that edit. See, I'm doing points only. We'll change that in a minute so you can see how it can generate some line work for us as well. All right, so that was that one. We've got a utility pole for the shed. We'll take a look at those in a minute. We've got this one down here, the point number 2. I've got access while I'm in here. I see this point number 2 off to the left here of my code, and it's one of my control points, but I don't remember the description because the description is not being plotted. But I've got over here this controls, I can edit my points. So if I edit my points, I see point number, okay, that's a code called hub. All right. So I'm going to come back to it. I'm going to find hub there. It happens to be under set control. That's good. I'm going to come up here and say hub. That's my hub and tack set. I have no description set, but I might call that H and T. And it's going to go on this layer called traverse. That's fine. You get the idea. Distinct points layer, separate points. My symbol is going to be, instead of that, I'm going to use something a little more conventional, say this. And now they're showing line types. That's why you see that blue line. So that's showing you your traverse line. You can have it show you that if you traverse the stuff, but we're not going to typically have traverse lines showing up in our drawings. I'm just going to say points only. So it's going to go here on traverse. I'm not going to change to a distinct point layer. I'm just going to let it go there on traverse. I'm going to use my second ID, my point groups. So there's a group called Trav, comma, survey. So he's going to put it in two different groups as part of this, excuse me, part of this definition. And the checkbox that we saw earlier where we said use groups by code, it's going to also go in a group it's going to create called hub, because that's its actual code. So it's going to be hub, trab, and survey groups all get created based on that. Again, whether it's non-surface, you can choose as well. So we'll say okay to that. Now let's save our code edits. Oh, excuse me. And excuse me. So then when we say exit, it's going to take us back to our dialogue. I'm going to say okay to have it reprocess. And you're going to see everything that needed to change. The fence stayed the same. It didn't change. But I got this up here. Let me set my resolution better. So there's my sanitary manhole. Now, how would you normally, if you wanted that to be shown in your drawing, using your symbols and your description, but you don't want your points in your elevation, then you would typically freeze the point number and the elevation, but you see that also turns them off on these other ones. That's why you would put these points on their own separate layers. And then you would move, this around where it needs to be. All right. Or you could do just like we did for our spot elevations. We would tell it to use text instead of the attribute. Okay, so, oh my heavens, I'm so sorry. All right, so we're coming along. We've got that. We had the hub and tack. We turned the lines off for that, but we have that. We see that that's on a layer traverse. And if we were to freeze, yeah, we didn't do separate separate layers for those. But let's go back and set that up so we could control that. Sorry, that's my inspector. So draw field to finish on my survey menu. And we're going to edit codes. And here was hub and tack. We're going to put the attribute block on separate attribute layers. We'll say both. So it's going to be those separate attributes. And we're going to do the same thing for our manhole. Set that on separate layers. Just say for the points, we'll just keep the symbol up here on its main layer. And we'll say okay to that. Save, exit, let it redraw, and to say okay. Now we should be able to freeze off these individual. So I'll turn the point numbers off of that one, and I'm going to turn the point number and elevation off of the sanitary manholes. So you see they're all labeled as they're supposed to be. I'll do it one more time here. Field to finish. Edit the manhole. Let's see the hub and tack. I did want to say the elevation. I did do that. That was fine. The attribute layout ID, instead of right now, it's going to have the elevation and then the description. If I look at, I want to put the description and then the elevation, I think, which is going to be one of these lower ones. I don't know what it is. There's description over elevation. description off to the side, the elevation below. I think that's what description at the top, elevation to the side. Maybe that's what I'd rather have. Trying to see if I can get them stacked up. No, let's see, H2. Description. Okay, let's use that one. And the manhole, I think I wanted to use 2 to get that out from under the bottom of the symbol. We'll save and exit. Hit OK, let it redraw. And now, see, for these, I can then freeze this individually, leave the description. And same thing for this one, I can change take the point number off, and it says that's a hub and tack as its elevation. And I've got another one wherever the other one is down here, I guess. Okay. So you get the idea of how you can control this a bit. And we can go through now. This point number 1, you see that little square? Because that's actually a double coded point. If I double click point 1 to bring up the editor, I see it's got this as a description, but nothing shows in the drawing, and it's all part of this fence line as well. But I see that it's a code FL. That's a fence line, so that's what made it draw that line. But it's also a code called CM, which is a concrete monument, and that's what drew the square concrete monument. And it's got this /4" DIAM, and that means something that we would normally see up here. And let's go and take a look at that code. Say okay. And we'll go back to field to finish. And we're going to edit our codes, and we're going to look for CM, which is also in our set control. We'll edit that, and it's going to go on, I think monument is probably, yeah, we don't worry about the layer right now. And set my attribute ID separate. Put that as 2, and now it's going to say a code of CM, but there's no description. So I'm going to call that conc mon. Okay, oops, let me. So I want that to label in my drawing, okay? And that's what I'm going to be. But if you remember, I'm going to say okay to that and save that. I look at my points, edit my points. Point 1 has FL, and then but for CM, it's going to use conc mon, but there's also that /4" DIAM close parentheses. Okay. So that slash code is what we call a special codes, and it's down here at the bottom corner. And if I choose in the bottom left group of buttons, and if I look at that special code, here's what all these mean. All right. And right here is that slash character, and that means to append the description. Right now, my description is CONC space MON. The slash parentheses 4" DIAM close parentheses is what will get added to the end of that description. Okay, because I turned the description on, then it should show up for us. Okay, there's a couple of things I know that I'm going to have to put a space in it. So we'll say okay to that. I'm also going to look right here. We're going to talk about this in a little more depth here in just a minute, but bear with me on these code table settings. If I click that, this is what controls a lot of the behavior. And there is a switch in here. It says skip the first and second symbol when missing the third control. That's not what I want. Let me see, there's one. Stop the line work again. Draw field codes without a suffix. Stop line work. No, oh, up here, use multiple codes, line work and symbols, line work and points, line work only. Yeah, I think that's, so use multiple codes. So our point number one has a multiple code. It has FL for fence line and it has CM for concrete monument. So when I have multiple codes, I'm going to process both the line work and the symbols. Or you could say, if you have a secondary code, suppress the symbol for the secondary code, but still process its line work. Okay, so if my FL had a symbol, like a little circle for the point, it would plot as well as the symbol for concrete monument. So we're going to just leave that set there. I think this should work. Nothing else that I need there. Nope. I'm going to go back to my concrete monument and change, because I know the description says 4-inch diameter. I'm gonna look at my symbol, and instead of SPT6, which is a square, I'd rather would use a circle. So I'm going to use this one here, and I'm going to plot it a little bit bigger, 0.15. And say okay, and save and exit. And let's see. Oh, edit my code one more time. I'm going to edit the points this time and change. And if I, right now, it's CM is going to spell out CONC space MON. But then I want to follow that with a parentheses 4-inch DIAM. So I really need to have a little space in there. As part of that, I will then save and exit. So now it's going to put the space in between the thing. So save that, exit, hit OK. And now you should see that changes to that. Where is my description? Should have generated that. Let me see. CM to use this description. Processing is on. Don't need the raw description, just this. Should work. Special codes right here. That's my slash code. That should do that. Oh, this append description auto space, that would have taken care of that. I didn't need to edit that point. All right, so I've changed that back. Right, so starts and stops, slash code, character up, and then offset width, third point, 2-point circle, photo like none of that. There's something that is suppressing that second description. Split multiple codes, we split them all. Split multiple Z label. And by the way, here's where you can, because you guys are all using Carlson Surf CE in the field. You can, once you develop your library and you get it right here on the desktop or in the office, if you come up here, you can export the Surf PC or Surf CE codes, and it will create a FCL file. Right now, this is an FLD file. It's a field code list. And over on the data collector, you have a FCL, a feature code list, or whatever it's called, whatever it stands for. So this will create that point and then, or that file, and you can just load that up on your data collector. And now you've gotten all this good work that you've done there, or here in the office, you can then take it straight out to the data collector. Now let me find out why. It's a setting. Substitutions. There's something that this is not triggering, and it's supposed to. It should add multi-points, point symbol attribute special codes. A multi-point. No, it's not a multi-point. Back to that, it used to be right in here, and with it said that you could, it would turn off the secondary codes description. Points. Let's set that, maybe that's what they changed it to. And we'll see what that does. Now I'm going to go back and edit that point number 1 because it said I can take that space out. It said it's going to auto space. We'll see if that works correctly. All right, save and exit. Process now, which, oh, there it comes. There it is. Okay. So now you can see why, what that did. You know what? There's 2 different points there. Yeah, there we go. The first one is the actual point on the fence line. It is point number 1, but it also draws another point number 1. If I look at the symbol and double click it, I see it has this description based on the CM code. Okay. So when I run field to finish, now watch the behavior, how the behavior is different based on what I do. I'm going to edit my code. I'm going to look at my code table settings. I had a multiple code. I'm up here in the upper right. And so use multiple codes. And I said line work and points. When I said line work and points, that's why it gave me 2 different points. And that's why it plotted the description for the concrete monument in that second point. If I said, like I had before, line work and symbols, then you'll still get the symbol, but you don't get the point. You don't get that secondary point. So right now, the only point is just the 1 point. If I select that by the crossing, I see up in the top, I've got 2. And that in that group, there's a block, which is the attribute block, and there is a add point. And the other one is just this, but it suppressed the point that goes along with it and only showed the symbol. But if we want that to show for both, then when we go to our code table settings, we have to tell it to show not just the line work for the second codes, but the line work, and not just the line work and the symbols, but the line work and the points. That's the only way to get that description out of there if it is done as the second point. Okay. So sometimes you don't want to necessarily have two points in the file with the same point number sitting right on top of each other. And so the way around that would be, you would put this back to where you had line work and symbols instead of line work and points. So how would I get that description to show up and the fence line to still draw if I had this sitting as line work and symbols? Got an idea? Any ideas on how you would do that? And it's a matter of how you do the coding. Okay. Right now, FL is the first code. That means it's going to get its point processed, and it's also going to do the line work. But when I said use multiple codes, so if I have additional codes beyond that first one, it's only going to do any line work and the symbol for that particular item. But if I want the concrete monument to show up first, and I'm saying for all of the secondary codes that follow the first code, don't do the points, only do the points for the first code. So what I would need to do would be simply out in the field, I would put that point first. So now my concrete monument code is first, and I've got a fence line, so that's going to govern the line work. Okay. So I'll now save and exit. And now when I process, you should see that come up. There it is. And where's my, oh boy, that that didn't fly right. Line work and symbols. Why didn't the line work? Oh, sorry. This is why. Wow, that's not gonna. Yeah, when I put that append on the end of that, it needs to be the end. Because they took slash 4-inch DIAM parentheses, and they took space FL, and they considered all of that as the append, but I needed FL to be a separate code. All right. Go to the settings, back to line work and points. It may be the only way to do that, is to leave that. Yeah. It's going to be what we need to do. So to get that then, and I can then when it comes time to do my, see, it's finding two. So I'm going to turn that one. Turn those off, but my FL, when I froze those, the FL is not on a separate layer, so I can't just freeze that attribute independently without turning them all off. Okay. All right. So I hope you're getting a sense of how you go about doing this. And let's take a look at the way this one was set up and done. And we can add a couple of additional items. I see down here, if I go back and just as a reference, look at here's where we're headed. So I've got these utility poles out here, and I've got another separate utility pole. So you see, I've got the actual utility line work from pole to pole to pole. I've got a separate pole here that's just like maybe a light pole, and this is a power pole or something. Because they're actually done with separate codes. Right. So let's take a look at that, and we come back to see here. It's a PL, that's a point on line for the property. We got a UP, which is not defined because it just got that symbol. So UP, and there's a LP, so a light pole and utility pole. So we're going to run field to finish again, edit the codes, and utilities. We've got there's a PP for a power pole. Let's find the UP and LP. There's LP and so that's a light pole. So the first thing we would do, we would take it out of trees and put it into utilities. And description, we might say light. Leave those as they are. Give it a symbol. This one, SPT 24, maybe. I don't see it's 44. 44. About to say 44. Ah, there we go. Although some people use that as a tree symbol, but it's going to be points only. So that's good. That was LP. Now our utility pole, we're going to, well, there's a utility pole in the trees because it generated based on the default. We'll put that in utilities. I'm going to take the description out, but I'm going to do that as my pole symbol, and I'm going to use a line type. I'm going to connect the lines up together here. And again, I can do it by layer if I put it on a particular layer, but I'm going to go ahead and assign it the one I need here, which is going to be an electric. There's the one with entity. I don't want that one. I want to use the one that's made that says continuous. See if I've got one. Then here's electric 1 and 2. Let's see what we've got. Electric 1 looks like that. So I want electric 2, which is this one. It's got an E in the line. And you have to do these here because it's going to create this as a line style and put it in your drawing for you. So the spacing scalar, again, I'm going to say 1.5 inches between the E's that it creates. And it's going to make them 1/10 of an inch tall for that symbol. Now it's also going to create those based on the current text style. So it should look, it'll probably look like a, a head, like an Arial typeface or a Helvetica looking typeface. And if you wanted, you could set that, you would, before you do all this, before you have it generate the line style, you would set your current text style to use a different font if you want to do that. But we'll just take that as it is. We'll say okay for that. We'll say okay, and we will save that one. Now that will take care of our utility pole. And I wanted to go back and revisit this PV, this pavement. That's that driveway down at the bottom. And that's going to be a closed figure when it closes. All right. So if you look at what we see here, you see that looks, we got like a gravel fill. So I'm going to tell it that this will be closed based on our point, our last point. And I'm going to go to my symbol. I'm not going to symbolize the point, but I do want to hatch the closed area. So if I look over on my line type tab, so I've got my symbol, no symbols, my line type. Down at the bottom, I'm going to say hatch closed areas. I'm going to select my hatch. I'm going to look for some kind of, either gravel or let's see, maybe concrete. Don't know which one this would be. So next, let's take a picture, see a picture of it. See, there's conch and there's concrete. Oh, let's just take conch. All right. Now we don't know what scale to make that. We're at a 20 scale drawing. Yeah, we'll leave it set to that and see what happens. So, okay, save, exit. Oops, go back to edit my codes and edit the points. And the last point I want to do is that last PV point over there, which was down here in the 40s. There's 44 and there's no more. So I'm going to go to the end of that point. I'm going to type this CLO. And again, just like we had up here with this slash code, that CLO is not it's not another code description. It is a special code. Okay. I'm going to save this and exit. And we're going to look at this special codes. And you're going to see somewhere here, I've got it set up to be there's CLO. So when you see the word CLO, that's just like you're drawing a polyline in the CAD system, and you're going to say close, and it's going to close back to the first one that was drawn. Say okay. Let's save, let's exit, and say okay. So there, you see, it created our fill because our number 44 now says CLO to close, and we told the code, if it's a closed figure, to draw the hatch. Okay. We did get our symbols. That is UP. That's our light. And UP did not. Remember we went over here and we defined the line type, but we didn't draw the line. And the reason is right here in the general tab, we said points only. Now, this particular line that I want to draw is going to simply be a 2D polyline because it's not representing elevations as an overhead power line. It's just a 2D polyline. So I'll say okay to that. Save, exit, and now you should see that show up. And it did, but it's like really not well, not well defined. That was a bad line definition. Let's try that again. Edit our codes, go back to our utility pole, line type. Electric 2C. Pardon me, let me turn that off. Apologize for that. All right. So that electric 2C. Let me default back to this 1.5.1. So that should have pulled this up here. I'll have to do it up here again as well. All right, so say okay, save and exit that. Now that should, there we go. That's what I was after. Okay. So that then goes to that hole. Again, I would set my text style to be something slightly different. Now, let's talk about a couple of companion codes that we have and these extra codes. So when you're drawing this kind of thing as well, what can we do with those special codes? So right here, if you look, let's look at the shed points. I've got the corner of the shed, corner of the shed, and corner of the shed, 5, 6, and 7. Just like we did down here where we said close, and it closed that off and then hatched that in. We want to be able to go out here and shoot this building and yet have it finish the building. Okay, so if you think about one way to do this was to get this corner, the shed, the shed, the shed, and then you get this other one back here, shed, and you would put a CLO on that point back here, and that would close it off, okay? But there's an even quicker way of doing that when you have two items here, or two sides rather, I'm sorry, not two items, two sides. There's another special code, and it's a rectangle code. Okay? And it does, it follows from, it behaves like this. This is not field to finish. You can also do this after the fact. You can go to the survey menu, and at the very bottom, there's a command called four-sided building. And if you choose that, and then choose a drawn building that has two sides, it will close it off as 4 sides. But now field to finish won't do that. You'd have to do that after the fact. Now, the other one, down here's another building. And that also works with when you only have one side. So if I say 4-sided building again, I'm going to pick this line. Now it went from 18 to 19. That's its direction. And so now it wants to know a building offset. If I say, let's just say 20 feet, it's going to go, it's going to ask me which side. Okay, so if I put it back that way, there's my 20 feet off to that side. So you can only shoot that. You could get by with just shooting 2 points, you get the 2 corner points, and then give it a width to a, and you can do that with this, with that particular functionality that works like that 4-sided building. So I'm going to undo that and show you how you would do that with field to finish, so you don't have to do it after you come back and edit your work, because if you have to redraw field to finish, you'll lose that edit. You have to come back to it. So let's go back to survey field to finish. And we'll talk about that as a special code. And here's that special code. It's called rectangle. And you see over here, there's general special codes, there's point symbol special codes, and in the right-hand side, the big one over here is line work special codes. And the one we're looking for is this rectangle, okay? So that says to close rectangular. Now we've also got some other things I want to point out while we're here too. Here's our PC and PT. And these are whatever you define them to be. They can be letters, they can be numbers, just whatever you want to use. But these are just some of the defaults. Down here's that ramp. Remember that one we did? There's also a parking code that creates a row of parking. I'll show you that in the help system in just a second. But this start and stop, I'm going to, oops. I'm going to put that as BEG and END. You could put, they had ST for start, and then stop, you would not put ST, of course. They had EL for end line. Well, to be consistent, I would call that, BL to begin line, EL to end line or something. But it's just called BEG and END. So we're going to begin and end. That's the way we mark where linear features start and stop. And we do the same thing for curves, PC and PT. And we've got close. You've got an offset horizontal, offset left, offset vertical, offset both, circle codes, smooth codes, gap, etc., etc. And some of these are really just ways to control your generation when you're out in the field. Again, when you're out there, I said, keep in mind or start to think along the lines that when you're out in the field, you're drawing the map as you go. You're drawing these polylines. That's why you're going to put like a CLO on the last driveway point to close it. You're going to use this rectangle code to finish off that shed. And when you have two sides to the rectangle, it automatically closes to make the four-sided figure. If you have only one side, then you have to give it a distance left or right, okay? So we'll see how that works. Now there's these other things here, this jog and JPN, join to point number. That lets you take a point, and even if it's not part of the line work that joins to something, you can say, I want to join to that particular point number, and it will create a line over to that point separate, as if you had surveyed those having the same code, but you don't even have to have the same code. It just draws that current line work over to that particular point, okay? And these jog codes work like the extend by distance command. It lets you go left, right, ahead, forward, and I'll show you how that's going to work here in just a second as well. All right, so let's make our change to BEG and END. That's going to get into some of our best practices where we start and stop. And the RECT, we've got the CLO, we've already seen. And let's say, okay, now let's go to that last point, which was point number 7, shed. So let's edit our points. And let's go to our point number 7, shed. And we're going to say rect, okay? Save and exit that. And say save that, exit. Say okay, and now you're going to see when it comes in, it draws that and it finished that rectangle. We didn't do this one, but we could have. Now, here's a shortcut. Every time I've been making these changes as we're editing this code table, I go back into draw field to finish, edit the code and redraw all this. But if you go to the survey menu and right underneath that draw field to finish, you see a field to finish inspector. Or you could simply edit the codes directly here. But let's go to the field to finish inspector. And that's going to bring up this little split view. Now, I don't, yeah, see if I bring that up, it doesn't let me see any more of this window down here. I'm not able to make that any better, but the code I'm after in this case, and exactly up here, I'm looking at that BLD code, 0.18 and 19. So if I scroll this down and find the code, there's BLD. I see, all right, that uses points 18 and 19. So that's that instance. And this is 0.18, this is 0.19. So if I were to use a rectangle code on there, I could go to 0.18 or 0.19. That's the last one. So I shoot this 0.18, I shoot this 0.19, and I'm going to change its description down here from just being BLD to be BLD rectangle. And let's give it 10 instead of 20. Now it's 10, it's positive. I'm going to apply that. And I'm going to say, go ahead and update the, I don't have the raw file to update. I'm not worried about that. So I'm going to choose that point number 19 and we'll say, yep, okay. So you see what it did? It went 10 feet to the right. If I said minus 10, apply that, it redraws it, puts it 10 feet to the left. Okay, so this is a nice little way of being able to, test out some of this stuff pretty quickly if you're using this inspector. Now I'm going to do something else here. Instead of rectangle, I'm going to do a jog code. And I'm going to jog, and that was, so I'm going 18 to 19. So I'm going to jog straight. Well, first, let's do this. Let's just take this out and have it redraw like it was. All right, so now at 19, I'm going to jog. We'll put in a jog code of I don't know how far apart that is. If I go straight, I may have to look up my codes here in a minute. So if I go T 25, we'll make that a 25-foot total length. Let's see if that's the right code for total. Oh, that went to the right 25 feet. I don't want it to go, I want it to go straight, but I want it to be a straight, not an additional 25 feet. To be a straight total. Let's go back to finish help. Let's find special code for jog. Let's see. So it'll be highlighted. We'll have to search it down to, there we go, jog, extend by distance. Turn off. All right, so this is a special code. Then you've got, it goes left and right, or R number, L number, or you just use positive and negative. S can be used to make an offset straight ahead, but using positive or behind, using negative. For example, building jog S 10.1 R5 L12 alpha or equivalent building jog S 10.1 5 minus 12 2. Okay, advances 10 units and then draw the closed rectangle on the right hand side of an existing line. Draws a closed rectangle. X. All right, so that extend it out a little bit. Let me that is a total length of 20. So let's do this. Let's survey with the finish inspector. All right, so I just wanted to get the distances correct. So I'm going to find that building 18, 19, and point 19. I'm going to say building, so 20 to 25. It's going to go 25 further out, which makes that 45 total. And then I'm going to go left 10. And then left 10 again. So I'm going out 25, so I'm at 45, left 10, left 10. Let's go right 10. So I'm now back here. So I'm 10 back at 35, then left 35, left 35, and then close. I think that'll work. We'll apply that and see what happens. There we go. So if we're out in the field, we got a building to locate, but you can't get to the corner because there's a tree in the way or whatever. You can shoot a corner, shoot the other point, and then give it the rest of the measurements around the building. Now, you will have to go out there with a tape measure, in which I was telling this class once upon a time, and I saw this young surveyor in a room full of old surveyors, and he got this strange look on his face. And I said, "You're not getting it. What do you not get about that?" He goes, "Well, I'm the guy that has to go carry the tape measure over to the corner. So if I've got to go to each corner anyway, I might as well just get a shot on it," because he'd only ever surveyed with GPS. He'd never done total station work yet. And he didn't understand the concept of sometimes you don't have GPS coverage and you're under too much cover or some kind of multi-path kind of problem. And so he thought if he was going to have to go to the corners anyway, he might as well just get the point. So he didn't see any use in it. So this is an idea of coming from the old days when we used to have to actually observe through an instrument what those codes are going to be. All right, so that's how some of these special codes are going to work. But out there in the field, what you have to do when you code these is you actually have to put in the description these things here, or make a note of it. If your data collector maybe doesn't have enough room to put all that in there, then when you come back to the office, edit the coordinate file to where you can add those things in. Okay. Now, same thing we would take, and we won't take the time to address this, like 18D, that's an 18 diameter oak tree. And so really and you see that slash oak. So what we would do is an 18-inch diameter. We'd work on that code. Let's go back to field to finish inspector. And let's look for that 18D. That's an 18-inch. I got 20 and 11. They're both there. So now I'm not going to use just one particular point. I'm just going to choose everything there. And so I'm going to change that well, no, I'm not going to need to. It's not the description that I want to change. I'm not changing the points. So that's, I need to actually define the code. So let's go back to field to finish and edit the codes. And we're going to find an 18D, which is right here. So an 18-inch diameter. Right now it's going to say a description of 18D. I'm going to change that description to be an 18-inch DIA. Okay. So an 18-inch DIA, and I'm going to go to my symbol, and I'm going to choose that symbol from trees, and we'll find something that looks like a nice oak tree for me. Let's choose this one. And I'm going to use, let's just make it, all right, instead of 1/10 of an inch, let's make it, say, a little under 2/10, so 0.18. We'll just keep it 18. The 12, we'll do a 1/2, that sort of stuff. We'll say okay. Let's see what that does. When we get back, we get the same thing with a 12 or 24D. We edit that. That's going to be a description of a 24-inch diameter. And we've got a 12P and an 8P. Now those are pines and not not a D. They're specifically a pine. So a 12P would be a 12-inch diameter pine. And now I would put these on the right layers. I'm not going to take the time to, track all that stuff down right now for us. You get the idea from that. Now this 8-inch diameter pine. Oh, I've got to set the symbols too. I forgot. All right, so here's going to be my uh, typical conifer looking thing. Just go with this. There's my 8-inch, my 12-inch symbol. Now, the reason I did that differently, the 8P and the 12P, because it's an 8-inch diameter pine, and this is just says 24-inch diameter, just general trees. Well, let's look at our points. What at the points? You see the ones that have the 18 and 24D, they have a slash oak. That means it's going to write the description of 18-inch DIA, and then it's going to append the word oak. But when he did, whoever the surveyor was, did this 12P and 8P, it was just a 12-inch pine and an 8-inch pine. Okay. And here's another 18D oak, and the rest of those follow. So we do that. Now save that, exit, and go okay. And then we'll see those now are going to come in. I've got now my 18-inch diameter oak, a 24-inch diameter oak. I forgot to put the symbol in, of course. So we'll go back to the 18D and the 24D. We'll edit the code. The trees, the 18D, let's make that a little bigger. Instead of 0.18, let's make it double that. So it's going to be 0.36. And a 24 is going to be 0.48. That's going to be, half-inch tall on the plat at our scale, which is going to be rather large. So for our pines, We'll set that one instead of 12, then it'll be a 24, so 0.24. And our 8 would be a 0.16. So exit, go. So now you're going to see influence diameter. Oh, forgot to do. All right, so the 18-inch diameter oak used 311. The 24-inch, this is one I forgot to get. Yeah. So exit. So now you're going to get those, and let's freeze those, and we'll just drag those down the way if we're going to use those to actually label in our plat. Some surveyors don't like to give out their points as part of their drawing. So every one of these things that you're using field to finish to do, some of these guys will actually, take the time and effort to draw text labels in for all these, and that's fine. There you can see the relative sizes. They're a little bigger. There's my 8-inch pine and the 12-inch pine. Obviously did that one slightly off. There's my 12-inch pine. 8-inch pine was 0.16. Inch pine. Registered when I typed it in, it's done. Exit, go. There it is. So then I would also do this, for these up separately so you can see them. Now there's our corners, and you remember uh, our code, that special code we had for a join point number. So if we had maybe this pole, there was a drop back to this shed, maybe it had supplied power to the shed. We can do in this particular shed, what was that point number? If I look at that, that was point number 7. And this point is point number 17. Now, watch what I'm going to do here. I'm going to say, let's see, I can do this with my inspector. And if I go to point number 17, it's a UP. Well, I'm going to jog straight 20 feet just to have it go on. But I'm also going to then JPN 7, join to point number 7. Okay, so we did the jog after that point. I guess I need to put this first. JPN 7, jog 20. There we go. Finally got it to work. So it goes on, and then we would So it's like that. So there was a power drop that we came from this pole. So we're out there in the ground, we're surveying, we had a pole, we had a pole, we had a pole, and it keeps going. So we just said jog, and I said S20, maybe it could be S100 because it crosses the fence and keeps going. We don't know. Um, but we also said, let's do a joint point number 7. So it draws this line over here, even though this point's description says UP, utility pole, and this one says shed. Okay, so the codes themselves normally would not draw accordingly, but that's what we have there. Okay, and that's how that part worked. Now, you can also do the same thing, for instance, these sanitary manholes. You could have it just like we did the fence line and this power pole, we could have the manholes draw sewer lines down there, okay? But let's go ahead and have it, let's go ahead and wrap this up, and we'll decide later that we're going to maybe we'll manually draft that because we don't know what the elevations are. Maybe we've got, another crew who's going out there getting us inverts, and we'll put 3D pipes in for us. Okay. So now we need to work on these the 3D edge of the roadway here. And because remember, we're looking at something like this. See how that generated, center line, these edges out here. And there's a couple of ways we can do all that. We can take this, which is a 3D line, and we could do a 3D offset after we've done this. Let's say all we did was get the edge of that road. Okay. And now one of the things that I would do right here, because that's going to be a problem, is because there's a 3D line that crosses this 3D line. If I look at that in my 3D viewer, whoops, let's try that one more time. If I look at this in my 3D viewer, I spin this up here and I say, well, look at that. And you see they're not, let's give it a little bit of a vertical exaggeration so you can see the fact that they are not, they cross and they're close to the same elevation, but they're not exactly the same. You see how that right there, you can see it a little better. See how one sits above the other? So that would cause an error in our surface modeling. If we can't have our brake lines crossing here, we're saying right where they do cross, we're saying at that point, I've got two different elevations. Well, that's not what happens. So normally what we should have done when we surveyed this in the field, we get a point here as an EP, and we come up and we shoot a point right on the corner and call it EP as well as PV. That was that pavement, okay? We'll do the same thing over here and go on. Now, because we got point numbering issues and that sort of stuff, I'm not going to, try to play tricks with those point numbers. I'm just going to, what we would do is I would normally, when we're finished, I would take this 3D polyline and just trim it back a little bit because I want to take this line and generate out the rest of my road. So we can either have field to finish do the road for us, and what we're going to basically do is this. Just like we saw these jog codes and rectangle codes was the same as a four-sided building, the field to finish code we're going to use for our pavement is going to be this, or analogous to this. We're going to go to a 3D polyline and we're going to offset the 3D polyline. So if I choose that, offset 3D polyline, I'm going to go by interval. I'll say, okay. And by horizontal amount, I'm going to say I had a 12-foot lane. Like right now, I'm on the edge of the pave. Well, let's call that edge of the shoulder. So I'm going to make a 2-foot shoulder. So I'm going to go 2 feet horizontally And vertically, I'm going to set that by a percent. And that's going to be a 4% slope up to the edge of pavement, which I'm, actually down on. We call these points EP, but, follow what I'm doing here. So I'm going up 4% from there to there. And now I'm going to repeat that command again by interval, and I've got a 12-foot lane. So I'm going to go horizontally 12 feet, and I'm going to go up again by P for percent. I'm going to go 2%. So I'm going to choose that and go out here. So that's my center line. I'm going to do the same command now, and I keep having to start and stop because I'm changing the percentage. And so I'm going to go another 12 feet, go by percent, and this time I'm going to go to minus 2%. Okay. And then I'm going to repeat it one more time. To the other shoulder, I'm going to go 2 feet by percent, minus 4% as the other shoulder. And I could even do, here I'm going to go 0.05 horizontally and up half a foot to there. Repeat it again, go horizontally half a foot, vertically 0. Okay, now what this looks like in my three-dimensional space is this. And we would put this back down to no vertical exaggeration. So I'm coming along, I got my roadway cooking along, I come up to a center line, I get to the edges and I've got a shoulder, and I've even created a little curb on the other side of the road. Now, obviously I've got a bit of a sharp bend in here that I would normally, not have if I defined that a little more correctly, or maybe it actually is that way, but in that case, it's going to go. So I would do that and then use that after I generated field to finish, and it only generated this, and then I would break this line out separately from here. Okay. That's a way to do that individually after you've brought it in the office. And there's nothing wrong with that. It's very quickly done. Okay. But if we do notice that out in the field, that what we're surveying out here is going to be some type of a constant structure, a constant width that we can create with offset lines, there's no reason we can't do that in the field. So back to our field to finish, we're going to do 2 more and wrap this up. So I'm going to now edit my codes, and those were EP codes. That's a road feature, that's an edge of pavement. Now, I'm going to draw those. I would normally draw those as 3D and 2D so that I could label those arcs. So I'm going to switch that. I'm going to set my color. Just leave it there. Set my symbol. I'm going to take that point and choose this null point. So it doesn't put a little X on it. It's just going to generate the line work. Okay. And I'm going to, over here on the line type, in by layer, that's fine. I can do it. You can have a separate offset layer. So you could, if you do make offsets, you could give it a different layer name so you could suppress that on and off. But I'm going to leave those unchecked there. So right now it's just going to draw that line. Okay. And if I edit my points, I'm going to see where those start and that was EP. So here's my first EP point, which is 45. And then it hits the curve. Okay, so I'm gonna actually do a little best practices. I'm gonna say begin, EP, EP. Now my last, there's my PT. And I think that's the last EP point, and I'm gonna say end. So now, these beginnings and ends don't matter if you don't have any other EP points. But if you are starting an EP and then it needs to end, and then you're going to go get another edge of pavement or another of the same code, if you don't start and stop those codes, it's going to connect to the last one. Okay. So that's why we get in the habit of anytime we're starting on a feature, we give it the start special code, which in my case, I changed it to be BEG. Same thing for EMD. All right. So I've now got my EP defined, and it's creating just that line itself. Now, if we want to go to generate those same type of 3D offsets, I'm going to go to the first occurrence of that EP. That's this 0.45. And another special code was the offset horizontal. And I went 2 feet. So I surveyed in this direction from bottom left to upper right. So I'm going to offset 2 feet to the right, and I'm going to offset vertical. Oops. Offset vertical. Oh, I don't know. What is 2 feet times 0.08? All right, so that will be that shoulder line. Okay, so that will get me the edge of the, I'm riding the shoulder. It's going to generate the actual, edge of the travel lane with these offset horizontal and offset vertical, right? So I'm going to save and exit the points. And then when it runs again, you're going to see it. See down there is my code. And as long as if I don't change that OH2 and OV to set them back to zeros, every time it hits the EP, it's going to keep that same thing going. Okay. Now, while I'm here, I've got another couple of things. I've got an IP for this IP code, which is probably, yeah, it's here in the trees. So I'm going to say IP, and that's going to go under set control, or is there monuments? Let's see, we call it set control. IP, and that's going to be it's called an IP found. IP found symbol is going to be here. And because I know this particular site there on the there's supposed to be property corners. So I'm going to draw the property line between it. So I'm going to put it on a layer called B dash. Property boundary. Format. There's separate layers. Use the twos. Line type. I don't know if we have a, so should be a property line symbol in here somewhere. Let's see. Start with this and see if we see one. Normally I would have there's a center line. I want a property line though. Looking for is fiber optic. That's flow line. The PLC right there, property line. We're going to use that, but we're going to do this one at, say, every 2 inches. And every 2 inches. Okay. And I think this should work. Save and exit. And now when that draws, it's going to generate that and my IPs, of course. Yeah. Do this all the time. Set the IP. Still told it to just draw points only. So I want to draw a 2D polyline in this case. Now it will put those property lines in there, and that's, with every 2 inches for the symbol. So there's that property line that would come here. At which point I would probably even maybe, if that was paralleling to that, let's do our field to finish inspector. We're going to go to point number 10. So point number 10 would be an IP PC. Which doesn't have any effect until we get over to IP number 15. Let's see if we can force it because it doesn't have a point in between. No, but then at 15, we need to do a joined point number back to 1. So at 15, JPN1. Now let's see. I need, if I've got an incoming tangent, IP, IP, and that is an arc. So 10 is a PC. Oh, not PC, it's a PT. There we go. So now, if you notice, when it drew this line, I have a PC here, a PT here. I didn't shoot a point in the middle. Remember I told you it takes 3 points to define the arc? Well, this is a special case, whereas if you have 2 points to define the tangent coming in, all you need to do is declare the PC and the PT, and it generates a tangent arc over to that point, okay? And then I just continued a join up to that corner there. So that gives me that. And now I've got this. I might want to give that a little bit of line weight. Move that one too. Probably a little too heavy, but you get the idea. All right, so now what we've done down here is we've now generated this road edge to be able to help us model. But remember, I did that one offset horizontal and the offset vertical. But now I would have to go in here and do that 3D offset like we did before, but I've at least got the first one generated. Okay, I can do it that way. But watch, this is even going to be slicker. If we go back to draw field to finish, we're going to edit the EP, and that's my road features, EP. Instead of having our code, well, first of all, let me take our code table. Let's go to the points, rather. Edit my point. I'm going to go down and find that first EP point, which was 45. And I'm going to leave the begin, but I'm not going to use these offsets at all. Okay, I'm going to save and exit that. And now I'm going to edit my EP. And instead of just drawing the 3D line, over in my line type, I have this little nice section down here called template. And I'm going to, first of all, select a template. I think it's looking for an existing one. Let me try to edit. Yeah, we're going to go to edit first. I want to make a new one. And we're going to call this one road edge, just as a template. Okay. And so this lets me build a template. So this little point, and it's called center, is going to be as if I'm doing a template for a roadway. But if I uncheck this right side, same as left, then the point that you see here, that's the point that I'm surveying. That's that innermost line. So I'm going to put everything on the right side over here. So go here for this right-hand side, and I'm going to add, whoops, first of all, I'm going to change. No, I don't want to change units, so you can make it inches if you want. Well, I'm going to go across here. I'm going to do a slope of 4% up. I'm going to go a distance of 2 feet, and I'm going to call that EOP. Because I'm shooting the shoulder, that's going to be my actual pavement. All right, so that's going to be that. I'm going to add another one, and I'm going to go a 2% slope up, and that was for 12 feet, and that's my center line. And I'm going to add the other side, which will be a minus 2% for 12 feet. And that's going to be my EOP again. I think it'll, no, yeah, so I have to call it EOP 2, all right? And I'm going to add one more, which will be the minus 4% for 2 feet. And that's going to be shoulder. Might as well call it 2. So there's the back shoulder. So I've got the first, there's my first shoulder, my left lane, my right lane, my next shoulder. I'm going to add a vertical distance of half a foot. And I'm going to take a horizontal distance of just a wee little bit, 0.05, half a tenth, and that's going to be my top of curb. I'm going to add vertical of 0, a distance of half a foot, except 45 instead of, because I already did the 0.05, and that's gonna be my back of curb. All right. And then, oh, what the heck, let's go ahead and give it one more, say 2% up for, let's go 6 feet. We'll call it sidewalk. Okay, so it's going to have a little section over there. All right. Now, obviously, you wouldn't do this unless you knew that every time everything you ran around that edge of that line that you're going to survey, that everything that we just defined is consistent all the way around the road. That never happens in the real world, right? Sometimes the center line is up at 2%, sometimes it's 1.5%, and sometimes, the curb's broken in a spot and you've got to change it and the width is not constant. So you're constantly doing stuff like that. But if you're, say, generating, you're surveying the flow line along a gutter face and you need to, it's a standard, it's a new construction in the parking lot at the mall. And so you're just shooting the gutters because that's the ones you're really interested in because you're doing some drainage improvements perhaps. And then you're just picking these other stuff up. So you don't have to shoot all of those different points. You just shoot the one point and tell it to generate this line work after you've done the work. So I've now told it to generate that. I'm going to say, okay, now watch what happens when it draws this. Okay, so it's going to generate all of that stuff, just like we did before after we came in after the fact and did the 3D offsets. So now just with those few points along that inside line, it created all of this different line work. And I'm going to now, after this has been done, I'm going to break this line, this with a standard break, so that I don't get those crossing. And I'm going to use this to trim, because this is now the resulting 2D line. I've got one's a 2D and one's a 3D. So now it's not going to give me those crossing errors. And so we'll verify that real quick with another quick 3D view. There we go. So now we no longer would have that crossing error. We're going to see the contours are going to be a little goofy, maybe. All right, so we are ready to roll here. We can see, what we're closing in now. After the fact, we would, close off those edges and shade in that pavement, turn on and off the different labels, etc. But let's go ahead now that we're done with this, and let's generate our surface. So we go to our surface menu, triangulate and contour. And at this point, we're going to go to the triangulate tab. We will write the file, and we're just going to call it site existing ground. Okay. We will not use an inclusion exclusionary. We did not set one up yet, but we're going to let it go ahead and do a shrink wrap with everything. We'll just say no reduction. It's going to have some edges that aren't defined very well, but we'll see what's going to happen here. Erasing the previous, that's fine. No zeros, these are all good to go. Densify my break lines every 10 feet should be sufficient. We'll go to the contours, draw the contours, and I think, see what was there? 500, 1, 2, 3, yeah, so 1 foot intervals. So 1s and 5s, detopo minor, major, labels, detopo major, major, index only, hide under. Let's go every 150 feet. If nothing is filtered, good to go, say okay. And we'll just grab our data. And there we go. We've got our contours. If we mute those, let's go to our the dash. That's what contours in mind. So the major contour I'm going to use as this 253, and the minor I'm going to use as the 251, and I'm going to load these or assign contour 2 to the minors. Contour to the major. And let's make them that using default. Okay, so that's what they would look like there. Let's try that. Oh, one more time here, triangulating contour. Not a big fan of smoothing contours, but just so you see, I can make it a little bit smoother here. That should work. Okay. Say yes. Get our data. There's our resulting topographic map. You can see the contours that cross the road, and you can see them as they walk up and cross the. So there it walks up there, and let's turn that smoothing back off so you can see them nice and sharp. Uh, or there yet, let's do. I'm gonna mark those. I don't know that I have the ability in survey. I don't. I could make those what are called hard break lines, but yeah, here we go. I identify and untag. I want to tag those. So this one, the 3D, this one, the 3D, this one, 3D, and 2. Shouldn't be 2 there, but fortunately it won't let me pick these as a group. Okay, now turn it contour. There we go. So as we come across the curb structure, you can see it hits the face of the curb, walks all the way up there till it gets to the top, comes across the back, and then back out the other side. If we look at all of this in our 3D viewer, we can see it. There's not a whole lot of relief There. Ah, see those little things? Those are like your concrete Jersey barriers, and they are what? There are something with one of my point codes. I'm gonna track that down and say something I'm gonna set up. So I do a quick select, and I'm going to look for my current selection. I'm gonna say um, 3D polys, include the new, say select all of the 3D polylines, including the new selection set. And so do this multiple times from the positive current selection, so the entire drive. Entity types are going to be multiple lines. Oh, there we go. Include in the new. Then better yet, let's do it this way. Let's just take. I don't think those buildings are 3D. I think they're 2D. We'll take that and well, I can take a peek at that in a 3D viewer. There we go. And let's then add a surface underneath it. Do a little exaggeration so you can see that it actually did generate a surface. Okay, and there's your contour, the resulting contour map. And get back down to one so it's ready for the next time. And restore my layers. And so that's basically how field to finish can help you do, some of your work. And again, the key that's going to make it all work is to be consistent when you're out in the field. And as you're collecting data, you want to be thinking along the lines of, I'm drawing the map. That's where you're going to get codes like begin and end, and COO to close, and RECT to create rectangles. Okay, and then get into that help system to figure out how, and here's a case of, join the point number. A lot of things that you don't have to do after the fact. You can just do them on the fly. Okay, we set up our concrete monument, gave it an existing, we just called it CM. Then we did a slash 4-inch diameter. Okay, we did this oak. We said 18D slash oak. So it's an 18-inch diameter tree. So every 18-inch diameter tree, it's going to be an 18D code. And then I'm just going to put a slash oak, slash sycamore, slash pine. In fact, that would be what I normally would have done for these, but they just called that code 8P and 12P. Instead of using the slash codes, it was specifically for a pine tree. So, but if you have a 12-inch oak, then you would have to have a 12O, so it gets to be a little confusing. All right. So that is field to finish as you would normally go through setting things up. And you can see, I didn't draw any of this stuff. I let the computer take care of all of that for me, just simply based on the coordinates. Okay. And the description in the CRD file. So that's the power of field to finish. And I know we have blown right through your morning break. My apologies there. We're going to go to lunch early as a result. So, but what we'll do is, you can save that. Think of the questions you might have. And there's one final thing I wanted to show you on field to finish, and we'll finish up the afternoon session with that. It'll take about 10-15 minutes, and then we will get into the deed processing stuff and the rest of the survey type tools. Okay. Any questions to this point? I'm going to let you go to lunch early here and actually add on your morning break time, which was typically a 15 minutes. You're going to get a 20 minutes. So we're going to actually come back at 1 o'clock, but that'll give you an hour and 20. Maybe get a little work done, some emails answered and that sort of stuff. But any particular questions that may have occurred? Anybody good or?
I think we're good.
Good. And you think it might be something that you're going to try to explore and get some efficiencies out of as your daily work?
Yeah,
I'm sorry, I missed that.
we were able to finish.
Okay. Um, I still didn't quite hear you. I guess it said you're looking at using that, or you're already doing it. Okay. All right. So I'll go ahead and we'll pause our recording. Zoom meet. There we go. So as we're looking at another example of what field to finish can do for us, we're going to see that without any break lines in our data, we've got a bit of a mess because some of the triangles are going to form incorrectly on these outside edges. So we're going to need to figure out where our break lines go and how we can connect those up. So if we take a look at the points, let's go ahead and go to the edit menu, erase, and I'm going to erase by layer, and I'm going to select a layer from the screen. I'm just going to grab one of each of those contour lines to clear those out. Now, let's look at some of this data in here. Again, we've got descriptions of ground shot, and then we've got a description over here on this side. We've got a 17, an 18, an 18, and a 17. Well, what does that look like? Well, if let's draw a little 3D line. And it's going to look like this. I'm going to go to my center line menu. Profile. Must be under surface. Yeah, I'm sorry. Under civil, it's with the road stuff. So under our surface menu, let's choose this bottom section, this quick profile. And we'll use a 3D polyline because I drew a 3D polyline. And I'm going to select that line. So from this 17 to 18 to 18 to 17 to ground shot, you see what it's supposed to look like here. Okay. if go up here is another spot. I go 17 to 18 to 18 to 17. So, and I look at the elevations, I've got 8.8 down to 6.6, 6.6, and then all the way up to 17. So I can see there's sort of a trend there. Let's look on this side. If I go across this area, I've got a 17 and 18 and 17. So I go from a 18 and a half to a 9.5 back to a 13.7. And so I've got these 18s are down at the 9-foot range, 10-foot range. The 17s are up at the, 14, 15 to 18-foot range. Right. So I've got a couple of indicators there on what this stuff needs to look like. There you can get a sense of what that looks like in terms of a ditch on the side of. Okay, so my 17s are obviously my top of slope, and my 18s are the bottom of my slope. Okay. So how can I figure out where these go? Well, I can take the time if I wanted and say isolate the points that just say 17 and 17, 18, 18, 18. And then draw the 3D lines, snapping to each one of those or typing in the numbers to see how they go, etc. Or I'm going to look at field to finish and let it do some of that work for me. Now, what we have in our points file is these little join to point number and begin and end and begin. You see the different codes. Now, that was done with a little bit of investigation where I didn't do those at first. I ran the stuff through field to finish and I saw where, oh, okay, then I see out here on these other ends, that's going to be where I need to put those codes in there. So in fact, I'm going to go to my points menu and edit the points. And I'm going to actually take out all of those things to show you what they looked like. Beforehand, and this was the process that we used. All right, so now it's just 17, 18 and ground shot. We'll save that. That's okay. And so now if I just go to my survey, draw field to finish, we'll see if perhaps that's going to work. All right, so if I just do that and say, okay, well, look what happens. You see anything different? Nothing there, right? And why would that be? Because we don't have our codes in that code table. In fact, I'm still pointing to this Sheets code. I don't know why it keeps resetting that. Let me see something. Do I have that set in my defaults? Oh, it's pointing to it, but it's grayed out. Take a look at it. There's a way to set that as a default, but maybe there's a setting somewhere that's doing that. All right, so I'm just going to be careful with it. So I'll go to survey, I'm going to draw field to finish. And I'm going to change my code table from the one I'm sitting on is this sheets code. And I'm going to set, and I'll make a new one. And I'm just going to call it on the fly. And make sure I'm in my little folder here. And we'll say open. So that's going to create it now. Because it's a new one, it's going to offer to import a code table from a different source to bring some things in. I'm just going to say exit. I'm not going to do that, but that's a nice little touch that they've added when it's new. They're going to give you the chance to go ahead and bring that in on the fly. So right now, I'm going to go to my edit codes for a minute, and I see there's no codes in here. So I need to create some codes, and I'm going to do those codes from points. So here's this code table by points. So I do that, I would say, okay. So it found codes of 17 and 18. And remember the other description was ground slash shot. That was that slash code that would put the description in as, an appended like you saw under the 18D slash oak and the CM slash parentheses 4-inch diameter, close parentheses. All right. So we don't care about that. We're just going to take whatever that's going to do, but it's these 17s and 18s, and that was the 17 was the top of slope and the 18 was the top of slope. But what we need to do is make sure that those two codes, 17 and 18, both are set to draw 3D lines for break lines. So I'm going to select them both here and then go down here at this middle buttons, and I'm going to choose edit. And so because I've got more than one chosen, it lets me do this and apply across both of them. So I'm going to go to my, the only thing I really care about is the line, and I'm going to put my line on a particular layer. There's a main layer. I don't really care about the layer, even at that. Let's just choose the entity. So if I choose this entity button, I'm going to draw a 3D polyline. And then you can choose either go in sequential order or nearest found. So we'll leave it in sequential order right now just to see if that helps. Nearest found might work, but if you get things, sometimes it'll go side to side across the ditch instead of down along the linear part of the ditch. And it looked like the point numbers were sequential the way they surveyed it. So we'll say, okay. And we'll say exit. And excuse me, and now we can see that if I edit any one of those, you see it's been set to 3D poly. Okay. And oops. Do those as well. Edit. I think I choose no attribute labels. I'm going to change my attributes to 2 just so I can tell the field to finish drew it. All right, so I've just very quickly looked at my bunch of points. I've got 17s and 18s. I'm going to draw lines. That's basically it. I'll hit save. I'll say exit and go. So it's going to redraw everything for us here. And there they were. Okay, so I've got some lines and I see that I've got some things that are crossing. All right, so, but for the most part, they're very linear, and I see that they go across the feature. So I'm going to go to my surface menu again, do a quick profile. This time I'm going to go across my screen entities. Say, okay, and I'm just going to drag across like so. And I see, well, there indeed, it does form as it crosses those entities. You can see that it does form that ditch, and it looks like a nice continuous ditch. We've got some issues back here that we could, at this point, just let everything go, kill this line, and come over here and worry about these fixes down here. So what we did beforehand, before I did those edits, was that I went through here and I started noticing that, okay, here's my 17, 17, 17. Those all went great. And then maybe 17 joined back up to this 17 over here is an 11. And then I get this 18 to 18 to 18. And so I sort of looked around at these to try to make a determination of how that worked. And what happens is in here, if you notice, they're getting everything sort of tying together all at this sort of the nexus of where all this stuff starts. And then we had this business right down here at 84 to 83 to 84, which is not going good because I've got 17 to the tops, 18 to the bottoms. So there's an 18 out here. There's no top of bank back out here. They've just gone to the bottom. And then I've got these two lines. This one, well, it's actually one line as it goes around and round and around, but it crisscrosses itself. So I would have to figure out where that's going to start and stop. Okay, so I did a little bit of investigation work, and here's where that happened. And we'll just go right back to drawing field to finish, edit the codes, and let's edit the points. Now, I wrote down those things, so I'm not going to go through the forensics of figuring all that stuff out just for time's sake. So on our first point number 10, we figured out that that needed to join to point 158. So then at a JPN 158. And point number 11 was actually the BEG, the begin. All right, so I'm going to save that. So 10 and 11, let's find 10 and 11. I'm going to exit and cancel. I'm not going to draw this time, but I am going to find point 10 and 11. So I'm going to go to inquiry, and I'm going to say find points by number 10 to 11. There they are. Okay, so there's 10 and 11. So right now, 10 goes across and joins to 11, but here's this 18 and 18 and 18. Okay, and it probably jumps across to another 18, or maybe that's where it starts. But in any case, that doesn't start. So I've said 10 is going to join to 158, which is this one over here. So 10 is actually going to be the start of this one, or the end, like 157, 158, and that comes up here and goes back to point number 10. Okay, but 10 doesn't actually go across to 11. I wanted 11 to start. So that's why I have that begin code on point 11. So when we rerun it now, this line here won't draw, but there will draw a line between 17 or 158 rather and 10. So that's going to get that other upper end of that one. Okay. So I'm going to go back now and finish those edits. I'll edit those points. And that was the 10 and 11. And then I had 52 and 53. So 52 was an end. And it did a join point number to 11. And then 53 was begin. So without this begin and end, remember that's their special code. That what I did was I do a begin, it reads ahead till it finds an end and it stops drawing, and then it finds the next code. Even though the next code's an 18, it won't draw a line to the next one until I restart it. That's why I'm doing that end. I'm tying up to a different point, and then I'm starting again with oh, except I'm putting them on the wrong point. I'm doing them on line 52. And it should be point 52. Sorry about that. 17, 18. There we go. All right, so 52 and 53, and then 127, which is, let's get the point number, not the line number. And that was a begin. So it started over again, even though there's other 17s before it, but it's going to start a new line here with this one. And then finally at 158, was the end. Okay. I'll save and exit that. And now, when I draw a field to finish, you're going to see those things take a little different shape. All right, so there's now, instead of joining 10 across to 11, 10 actually joins to 158, and 52 joins to 11. So that's that 17 that comes across like this. And I suppose it could have gone 158 to 10 to 52 to 51. So it's 50, 51, 52. And then that joins back to 11. It could have joined up here to 10. And then maybe this line in here between 94 and 95 might not have been in there if I close this a different way. Okay, so you see what's going on there with that. And so we sort of fine-tuned that. And then we also came over here and we saw where we started and stopped here. So the origin of this 18 at 126 went all the way up here and crisscrossed over there, and or same thing with this 127. And it had 127 crossed over to this and crossed these other lines. But anyway, so now what we have, after we figured that part out and we look at it in 3D space, we've got some good break line information. Perhaps we could have used an extra little point out in here, but we don't have it. So the assumption is that that's, that's going to go that way. Or if we put in a point over here, we could straighten that out. But again, what we have are our break lines that we're going to use now to go back to do our field to finish. So when we do triangulate and contour, and we'll just leave everything just like we had it, same file name and everything. We'll say, okay, yes to overwrite. We'll select our data, and then we're going to see what layer that's on, layer 18. I'll freeze the break lines. Now you can see the contours are much more representative. And if we start to look at that in those with their quick profile, this time we'll actually use a surface file and we'll choose our field. G, and we'll just come across like this. And now you can see as it goes down, it crosses the bottom there. And if I move this around, you see everywhere I walk down there, you see that ditch is nicely formed. I don't have all of those weird looking triangles that let's see. So you see that ditch structure in the profile below as I move down across the actual surface. That's really nicely defined, those ditch structures, and it's no longer got all of that haphazard jumbled mess. And if I look at the surface file directly, and these are the contours that it generated, the same as the ones we just drew. Okay, now you can see it's nice, smooth ditches, and right up here's that little mess up here in the corner that we could have figured out. Oh, hold on, let's see. Sorry about that. This little jumbled mess up here in the corner that we could have, straightened that out, but you get the idea. We very quickly took field to finish and used it to generate the break lines necessary for us without us having to go through and play connect the dots. Okay, so that's how we're going to use, how we would use that field to finish as a tool beyond what we just did before, where we use it to actually craft the plat that we're going to draw. And we used it to help us do some modeling. Okay, and we can throw that code table away. We just used it as a one-off for that particular effort. Okay. Any questions on any of that stuff? Good to go?
Good.
Okay. So let's go push ahead now and go to our next bit. And we're going to talk about some deed processing. I'm going to show you a couple of tools here, and I'm going to let you try. We'll maybe try, but I think this is it's an obscure tool. It's kind of hard to do. I want to talk about this one though. And these files are here. There's a text file called deedtext.txt and a deed reader settings. And it's as if we had scanned a deed. We got the text in to a text file. We brought it in, and the system's going to recognize certain key words and create the bearings and distances and calls along that deed description and actually generate the geometry just from the words in the file. Okay. I'm going to talk about this because I don't really want to waste a lot of time going through it because it takes a long time to sort of fine tune and get through all of the different errors and things that you're going to get. And here's the problem that you have with this. This works very well if all of the deeds that you want to work on are all written in the same type of language and they all have the same type of calls. But I get some deeds, I'm sure you have as well, that the descriptions might say in space 27 degree mark 15 minute mark 26 second mark space E. And yet in the same description, you will see them say North, or N without a space, or 27 instead of a degree symbol, you'll see them say 27 DEG period or DEGREE. And because of that inconsistency, it's just quicker to code the deeds in individually. Okay. But if it is consistent, it's an interesting little tool. So I'm going to leave this exercise though to you on your own, and it starts here on page 71, and all the data files are there for you. But there's a lot of fixing that you have to do. All right. So what we're going to talk about next though is a similar type thing where we're going to put these in and then see some tools that we're going to use to resolve this particular deed, and then how we're going to fix that from when we see points out in the field, and how we can do a correlation back to our deed. Okay. So we're going to go back to our drawing, and we can, let's just close this off and make a new one. And we'll keep the same defaults there. We're going to choose our file to be, I'll hit set, choose my folder, and I'm going to call it deed processing example. That should work. Say next. And we'll let the wizard set us up with a new coordinate file of the same name, no import. We'll say next, and that's going to come up there. Now, we did have a file. I want to see if there's anything particular in it called deed processing. I think it's empty. Yeah, it is. All right, so this would have been, we could have opened that file instead of making this new one. Regardless, it doesn't matter. All right, so we are going to take this deed that we had showing here, and we're going to code it in. We're going to start over here at our POB, which is sort of an odd point to start with it, but typically it's going to be at a more of a common corner. All right, so we're going to start here, and we're going to work our way around it and come back and generate this line work. Okay, and so a couple things that happen. If you look at that deed, you're going to be reading off a deed description. You're going to be typing these values in and starting to create those. There's several ways that you can do that. You can simply come over here and start drawing a 2D polyline, put it on a layer that you want. You click a point. Let's just say, okay, I'm going to click a point, and now I'm going to go, what's my first call? North, 25, 30, 45, east, 165, 45. So I'm going to do a D for distance of 165.45. Now, how do I define the direction? Well, I'm going to go by A for angle, and it was a northeast code. So that code is code 1, and it went 25.30, 45. But let's say I accidentally said 55. Okay. There it is. And then I would keep doing the next call around my deed. But I'm just doing this as an example. So there's that. And if I annotate that line, I would see that, I've got a bad bearing compared to this one here. It should have been 45 instead of 55. All right. Well, if I noticed that, then I'd have to go back and recreate all this kind of stuff and do that over again, just like I did before. But there's another little thing, just like raw file processing helped us with our Kogo commands, we can, I'm going to go ahead and get rid of this. We can do a similar tool, and it's under our survey menu now. And these are the deed blocks of commands. There's this block of deed commands. And I'm going to do an enter deed description. And the reason I'm going to do this instead of doing what I just showed you, which would have worked if I had done correctly, but this is going to give me the opportunity to store and save what's called a deed file. Okay. So every time I start to put in a deed, it's going to, all I do is I name the deed, I put the property in, I put the next one in, then the next one in, then the next one in, etc. So I set up some layers up here where I want my deed to be where my lines and curves are going to go. My points are going to go just by generic thing there. I'm going to enter my property bounds. I'm going to traverse by using bearings. I'm going to create complete Carlson points. I'm going to label the lines and arcs. And that's where I can set up these defaults from the annotation defaults. And now here's my first deed name. Well, maybe that was, Johnson and wife. Okay. Johnson et Ux. That's what I love about Latin. It's the only place you get to call somebody's wife an ox or an ux. So now I'm going to draw the line work. I'll prompt for descriptions. I will create a polyline so it joins all the edges together. I'm not going to bother with elevations. And right down here is my, whether I want to create a raw file, you can do it if you want. That's much like we saw yesterday. But I'm going to put this in a deed file. And I'm going to put this in a new one. And it offers the same name of the file name .pdd. And if I choose append as my setup here too, then the next time I put a new deed in, it's going to take that description for the next one and append it to the previous one. I can do another deed. And so I get 1, 2, 3 different kind of things. Okay. So I choose OK. It says pick a point or point number. Well, I'm just going to say, I look at my coordinates down below. I'm up here sufficiently into the like thousands area. So I'm just going to pick a point. Maybe I'll just type 5,000, 5,000, just as a, for giggles. And that's going to be my point of beginning. Now, slightly different format to enter because I told it bearings. I'm not going to give it a code of, type the code, hit enter, and then type the angle like we did on the last thing that I showed you, drawing a 2D polyline. But we're going to put this in this format. We're going to put a Q in that represents the quadrant. And it's just clockwise from north. Northeast bearings are 1, southeast bearings are 2, southwest bearings are 3, and northwest bearings are 4. So if we precede the angle with a bearing code, or a quadrant code rather, which is 1 in this case, and my bearing now was 25 point, so there's my degrees, my decimal. Now the minutes were 30, and it should have been 45. Again, I'm going to put in the error just to show you how this is a nice little way to fix some things. And I'll hit enter for that. And the distance now, and notice it also gives me the opportunity to type it in with some optional different units like varas, rods and chains and meters, all that, but distance in feet is my default, and that was 165.45. So 165.45, I hit enter, and there it is, and it not only start things off, but I don't have to go and choose to annotate. It's ready to go. And it wants to know a POB for there. Well, I'm going to call that just corner, COR. Okay. Now, what's my next one? Well, I see I'm going south 45 east for 200 feet. So the bearing is a southeast bearing, so it's 2. And it's 45 degrees. Now I don't have to put in the decimal 0000. It assumes all that if it's missing. So quadrant 2, 45 degrees for 200 feet. There's that one. Okay. So the next one is a straight line. It's a 3, 25, 30, 30 instead of 30, 45. So 25, 30, 30 at 156.78. So that's going to be I got to give the description. There's a corner. So then 3, I've already forgotten it, 25, 30, 30. So 3, 25, 30, 33, or 30. Either way will work. And the distance was 156.78. 156.78. Okay, so now it's asking me for that. That's going to be also a corner. It's all there by default. So there's my corner. And the next thing I see is that I've got a curve with these values, a degree of curve, a radius, and an arc length. So the 200-foot radius, 175-foot arc length. The assumption is, with nothing else to go by, that it is tangent. So we'll use that to our advantage. So we're at that point, and now one of the options in my choice down here is to do a curve. So I'm going to type a C because that's the capital letter there for a curve. And it gives me some options here. You can stipulate a out tangent. You can use a curve calculator and bring that up and figure out some things. But my default, the radius value, is 200 feet. So I'm just going to type 200, hit enter. And now it's going to go right or left. It's going to the right. R or plus mark, either one. And it now wants to know the arc length. But you see, all of those different things you could have if you had the information, but this is all that we have and all that we need to define that, with the assumption of it being tangent. And that arc length was 175. And it too is going to go to a point. I'm just going to keep calling all of these corner. All right, so I'm now around to the bottom corner of my D, and I'm going to go up this time north 10, 15, 25 west for 200 feet. So it's still looking for a curve. If I were to hit enter at this point, it's still looking for another curve. You see that's in the angle brackets there, the C, but I'm not going to be doing a curve. I'm going to be putting in my bearing code. So that's going to be my option there. So I'm going to go as a 4, and it was 10, 15, 25, I think. 4 north to west, 10, 15, 25. So 4, 10.1525. And for a distance of, again, 200 feet, 100 feet, it is a corner. And now I'm going to put in the last closing leg, which was north 25, 40, 30 east to 49, 30. So that's a northeast 25, 40, 30, 25.40, 30. And the distance was 49.30, 49.3. And we're going to call that one N to distinguish it. And I'm done. Now, to exit this, you don't want to press escape because that's going to interrupt the saving of the deed file. So I'm going to type E to exit. So it closes it nicely. All right. So notice it says, okay, I appended this file called deed processing example, and I wrote a deed called Johnson et Ux, and now select the entity for area calculation if I wanted to calculate any further areas. Let's do it here is that one, and it didn't calculate the area because it wasn't actually a closed figure. So if I look at that and I zoom in down here, now this is where point number 17 and 1 should have closed off to be the same point. And we're going to see, of course, that it didn't. And I'm going to take my points, move points with leader. I'm going to say my point 1. I'll put up here as my POB. And point 7 is the end. And I'm going to see that it is, there's the point 1 and point 7 if I do that same. And I zoom in there, I see that they don't exactly meet up. Okay, there's where it starts and there's where it ends. So there's a little bit of a gap. In fact, if I want to see what that is, I'm just I for inverse. And I'll go from that one to that one. And it's not much, but let's see, what do we have here? We had 0.013. All right, so it's not too bad. But we also say, well, oh, you know what? Actually, I noticed that my bearing up here is bad. So what do I do to fix that? Well, I don't want to re-enter this whole thing. So I'm going to go to my survey menu and I'm going to choose process deed file. That was the deed file that I just created called deed processing example. There's my Johnson. And if I had other deeds, they would all be down there. I could look at each one of those together. So I choose that one. I choose the edit button and there it looks familiar, right? I've got all of my different calls. I've got the quadrant codes. I've got the distances. I've got the bearings. And here they are in separate columns. If you want to change that instead of 3 columns to just 1 column, you can do it like that. You'll see the codes the way you typed it in. So instead of 3055, that should have been 3045. And that's all I need to do to save that. And I will say, okay. And that has now made those edits. I will save. Okay. Then I could, at this point, I could draw it over again. So if I say draw, do those same things here. So you see it drew it, but it drew it right over top of the old thing. So we're going to go out here in a minute and change that. I'm going to say exit to finish that. I'm just going to get rid of all of this. And I'm going to repeat that deed processing. Load that up, or I don't need to actually do the edit. I'll just draw it. So now there is that. I can look at my reports. And this is where I'm going to see my closure. Say okay, and there's my deed name, starting coordinates, of 5,000 in feet. There's my calls. Okay, and there's the curve that we went around. There's my ending coordinates. So you see I've got a misclosure of a hundredth or so. So I've got a closure of 0.01 at north 24, 35, 36. It's 1 part in 99,000. So that's about as good as you can expect to get. So we would say, happy with that. So we now saved that and it's put the descriptions down here. And, but the points now are slightly different. So I'm going to draw my points again. So just one thing to be aware of. If you go back and make edits to that file and you do something that changes the geometry, even just a little bit, let's go back now and move those points by leader. And then this is just text. We'll get this out of the way. And then let's change this line to a different color so you can see the get down there. Now, if we zoom in, you see this line now that started and stopped. It still starts at the same point. That's our start point. That's our 5,000, 5,000. But because we made the edit, it actually shifted the endpoint from over here that it was the first time to up here now. So I need to, make sure that I move this point. So if I take that point there and I move it up to that endpoint there, so I'm snapping to the endpoint. It says, hey, you want to update? Yes, I do indeed. So now my point has moved up there. And if I just make the adjustment there so that it snaps back to the point itself, okay? So be aware that even though we did make the edit in our deed file and we redrew it, the original points that we created when we entered it get left behind in the process. They're not part of what we're doing here, okay? So that is something, that's pretty nice. And let's say we've got 10 deeds that we have to put in, and then we're going to do the next deed. We would just go, once we've drawn this, remember we started this down here at this coordinate. And so let's say we had this property over here, we would simply go to survey, enter deed description. We would give it a different, this is going to be Smith and husband. And it's going to append to this example file. We'd say, okay, and then said pick a point or a point number. So you could then start up here at point number 2 or, wherever it happens to be, and it ties all that stuff together. So let's say we started that one at, say, point 2. We called it a BOB. And we went up. Let's go to, we'll just kind of see if we can make a figure here. Let's go to the 145, 50 feet. And let's say it went then to, we'll parallel this line. We would southeast, so that's a 245. And it went, let's say 185 feet. And I have no idea what that's going to be. I'm just going to sort of guess it. All right, let's come back parallel to that. So northeast, so it'll be southwest, it'll be a 3. Up, then a 345. for 50 feet. Okay, and then we did a, so the southeast, we went to the corner, then we went to the northwest, 45 degrees at 185 feet. So that's a perfect closure. It joins right onto our other property as a deed. And I type E to exit. And now I've got two things. Okay. So if I even erase it all, I go back to my process deed file. I choose that deed file. There's my two properties. See, there's my one I just coded. There's the one we did the first time. So that looks like. So I'm going to select them both now and choose draw and say okay. Put them both, yeah, there they are. And then we'll exit that. And I could even draw, locate my points as well, so that they're going to pop in there where they are supposed to go. And everybody's happy. And I've got a little bit of misclosure on my first one. This one is exact flat, but it drew everything around. So if I needed to redraw this deed stuff and move it to a new starting location and make any edits, and it can recreate that stuff for me. All right, so that's an example of that. And much like the raw file, it keeps that deed file that I can then use to edit some deeds. Now, excuse me, we're going to do a little example of how we might find some things that are, how we're going to correlate some points. So let's say this is what our deed calls everything to be. Let's take one of those parcels, or even both of them. Let's say we'll select them both. And we'll just right click and choose copy. And we're going to just take this out over here off to the side a little bit. Okay. Normally it would be, from 5,000 to something up at state plane level. I'm not going to, have to drag that around. I'll just show it to you how we're working on this. So I'm going to take it there, and I'm going to also select that, and I'm going to choose rotate. Right click and rotate, or choose it from the toolbar on the right. And I'm just going to rotate it here about the center, and I'm going to give it a little bit of rotation. You can see, in fact, quite a bit of rotation, but it's slightly different than it was there. Now I'm going to also do something here. I'm going to take this first quad. Now remember, there are 2 points, or there's a beginning point and an end point there, and they no longer actually fit. But I'm going to just grab that and drag it down to that point so it shares a vertex there for a reason. So I've made a slight change there. I'm going to come down here to this corner point. I'm going to just click that grip, and I'm going to move it to the inside a little bit. And let's go up here now and take this corner and move it a little bit up and to the left. It doesn't matter. Just doing some slight little tweaks. Okay. Now we have down here a bunch of points. 1, 2, 3, 4, 5, 6, 7. And these are points that were generated from the deeds. Then we had up here, let's I'm going to erase just had, let me see if I get rid of the descriptions. All right, so now let me get these points moved out of here. I've got point number one. No, sorry, it was 12. And point number 8. And then point number 2 is for this key down here. And they all are the same point, but all right, so I've got points number 1 around to 7, and then point number 8, 9, 10, 11, and 12, 12 and 8 being the same point. But let's say that I had something over here that was similar, and now we copied the line work up, we rotated it, and we tweaked a couple of the points a little bit. We got some mismatch up here. So what we're going to do is set new points along this geometry here. And you can either draw locate point, snap to the endpoint, or go to the COGO menu and choose create points from entities. And we're going to call those, these were starting down here at 1. I'm going to start this at 101. So, okay. And we'll take polylines. These are all polylines. That's perfect. Any curve points, I'm going to skip any radius points and midpoints. That's fine. I'll say, okay. I'll choose this. I'll choose this. And now these are going to happen like that. Created 9 points and avoided 3 duplicates because you had a duplicate here and you had these up here. So I've got 101, 2, 3, 4, 5, 6, then 7, 8, and 9. Okay, so those are points that we found in the field, let's say. And I'm going to just change this to be yellow, see it differently. And normally we wouldn't, of course, have those lines drawn. We just have a bunch of points and we would compare them. So I'm going to keep them here just so we can keep track of it easily enough. All right. So we're going to do a command under the survey menu that says, it's in our deed tools right here, and it's going to be called deed correlation. So I'm going to choose this, and it's going to ask for a file to process. I'm going to choose, make a new file. I'll call it deed processing example DCF. That's my deed correlation file. I'll say open. Now, what I need to do is to create a bunch of point-to-point comparisons between my 2 sets of points, those I found in the field or my survey point and my deed point. Because I'm going to try to bring this deed up to my field points to match them the best way that it can. Okay. So let's start doing that. I've got, remember down here, we started with 1, 2, 3, 4, 5, 6, 7 around that figure. And then we're at 8, 9, 10, 11, 12 around this upper figure. So I'm going to start with my first one. I'm going to add a point. My survey point was 1. And I think it's up there. Well, we'll see if that was 101. And my D point was 1. Let's see, screen pick. Let's see what they say. Pick the survey point. All right, that's that one. And then the D point. I think it's that one. All right. So that was 7. I'm going to edit. that and change the 7 to 1. All right, so I've got that one. And let's add another one. We're going to add, let's say we found, I think it's 102. My screen pick there, I'm going to say that point up there. And now my deed point, I'm going to choose this point number 2. So 102 to 2, I'm going to add a point. Screen pick, in this case, I've got that corner and that corner, 103 to 3. I'll add a point again by screen picking. I would choose this one. No, let's say we didn't even have that one. Let's say we didn't find that one. We're going to get this corner here and then compare it to that corner. We'll add another point by screen picking, say this one to this one. And because I know I had a 0.1 and a 0.7 down there, you've got multiple points. You can do more than one. So if I say 101 compares to 1, I'm going to also add a point that was 101 compared to 7. Okay. Same thing up here. Excuse me, I have this 102 is the same possibility as 8 or 12. So I'm going to say I'm going to add a point 102. I'm going to compare it to 0.8 and 102 to 12. And I'm going to add another point, and this time I'm going to grab that one there and say that one there. I'll add another point, screen pick. I'll pick this one up here to this one down here. And again, you wouldn't necessarily find all of these, but let's say the ones we did, and we've got a list of points, of point pairings that are going to show us, you know, this is what we suspect. Let's take a look at how this works. Now, the alignment direction. What this means is you're going to either be trying to, excuse me, take your points you found in the field out there on state plane, and let's say you've got another drawing where you've got the deeds all plotted up and they're down at 5,000, 5,000. So you may be wanting to try to bring your field points down into and rotate into your deed space. So that alignment direction would be survey to deed. But instead of doing that, because I may want to take those same points and go out in the field and stake them out in their proper location, I'm actually going to be going deed to survey. So that's why I've chosen that option, is my alignment direction is deed to survey. So once we figure out how to do the alignments between these, it's going to offer to let us bring all of that deed information up to match my field found information. Okay. And so we got a bunch of tools down here that's going to help us do that. Let's look at the inverse report, and you're going to see what that's going to do. It's quite straightforward. I've got a column on the left are my survey points, and the column on the right are my deed points. And so this is simply from 101 to 101, of course, is 0 to 102. So 101 to 102, there's my deed call, 38, 58, 40, 165, 45. And that is going to correspond to my deed. Actually, here's my deed called north 25, 30, 55, east 165, 45. But when I found it in the field, it was, you see there's a rotation, north 38, 58, 40, but the same distance, 168, 45. So this is just doing a process of sitting on the point that we declared, and then it's going to inverse around all of the different points, both in the deed column and in the survey column. Okay, so if you look at those, you want to try to maybe get a sense of, here's that 165.45 in my survey points. Those are all 165.45. They're all 165.45. So it looks like they're close there for that one. But there's a 244.600 versus a 243.5, 213.24, 213.20, no change there. 212.905. You get the idea. Okay, so that gives you some information. And that's all it does, is just report on those inverses. If you do a compare before aligning, then it's going to do all of those pairings that you did, 101 to 1, 101 to 7, 102 to 2, to 8, to 12, 108 to 10, 107 to 9, 103, etc. This is what they would be. Now, ideally, if everything were exactly the same, now we tweaked the positions out here a little, but ideally that distance, the bearing's going to be different, but the distances should all be basically the same or close to the same. But that's just telling you for each of those point pairings, that is the survey to deed comparison for each of those points. Okay. So now we're going to actually do check an alignment. So let's say we decide, we figure out that we might want to hold. I'm gonna exit this for a second. I'm gonna save it. I'll exit this. I'm gonna zoom in so I can see the darn point numbers. All right, now I'll go back to this, and if I do a check an alignment, I need to tell it from my deed points. Well, I zoomed in on the wrong area. My deed's going to go to survey. If I hold or do a pivot point, I had 1, 2, 3, 4, 5. Let's say if I hold point 5 and I rotate into 2. Okay, that's just going to be my guess for whatever reason. And I'll say, okay. And it's going to say, okay, well, if you hold 0.5, which was the same as the survey 0.105, and you rotate everything, holding that point and rotating, matching the rotation as 5 to 2, then that's going to give you this as my rotation and this as my residual distance. And so what I want to find when I do all of these particular rotations and adjustments is I want to find the one that has the smallest residual distance. Okay, so you can try that, various different ways that you want to do it. But we have another button here, and that's just a way to check something. But this next one, find the minimum alignment, that's going to do that for you mathematically. So if I choose that and it says, okay, well, you need to hold point number 2, which is this point up here, and rotate into point number 7, okay? Or back down to that initial alignment to 1. And that's going to give us that residual distance at 0.369, which would be the smallest one there. Now you see I've got the deltas, the delta X and Y. See, I've got a little better than a foot here at point number 10, 108, but these others are pretty tight. Look at number 1 and 7. See, they're pretty close. These are all pretty minimal. Okay. So that's going to be the actual minimum reduction for everything. If I exit this again, we get out here and see them both. Sorry. So if I do that, I'll find the minimum alignment. There it is, 2 to 7. Right there. That's what it's computed to be. Now, you don't always resolve everything just by those minimum numbers, just so you all are well aware. As surveyors, of course, you're going to have preponderance of evidence and seniority rights and all kinds of different things that you're going to have to consider as to which points to hold and how to move these around. This is just a tool that's going to help you find some mathematical differences and best fits. Okay, so I found that minimum alignment, and I can now apply the alignment. Now, when this comes up, see, I've got the full capabilities of bringing all of my points from down here up, even if I didn't have them in my pairings. We can go ahead and bring all of the points together up with it, or just a particular ones. So right now it's getting 1, 7, 2, 8, 12, 10, and 9, and 3, and 5, and 6. Okay. Those are going to be the ones, those are the points that we're going to align. And you look down here at my translation: first point, first source, first destination; second source, second destination. There's that 0.2 to 102 and 0.7 to 101. Okay, so that's holding 0.2, rotating into 0.7 is my minimum, and that's going to be how that's going to work. But because I am taking my deed points up to my field or survey point locations, that's the set of points up here, these range of points that I'm going to align. Now, you could have taken them, if you say all, it's going to be all points, but you don't want to do all points. You just want to do the points that are there from the deed correlation. And let's make sure that we've got them here. I'm going to clear this out, and I'm going to say 1, 2, what did we get, 12? So 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12. Yeah, so we'll say 1 to 12. Okay, you could have a point group to help you as well. So we're going to move all of these points up as part of this, and then down here, and this is really important, because I did this command and scratched my head for a month before I understood what it says. It says align the screen entities. Yes, I do. I want to take these drawn deed boundaries and bring them up to my new space and my new rotation. So I'm going to have that checked, and that's what I'm going to apply. And I'm going to say, okay, and here's the part that I didn't catch the first time. I wanted to point it out to you. It says select entities. Reading the line above it, it says select the objects that you want to align. In other words, the things in the drawing. I could have, a house footprint, driveways, and, all kinds of things that have nothing to do with the points. I'm going to bring them along for the ride. But it says, and this is very important that you understand, it says points excluded. In other words, don't select the points because the points are already going to be moved. They're going to be aligned. So they're going along for the trip. If I were to select the points in what I select now, it will take, of course, the line work and move it along, but it takes the points and it moves them along that same distance and rotation, but it does it after it has already done the alignment. So they get a double adjustment, and the points then get thrown off, twice as far as your intent is. So make sure you read that line above. It says points exclusive. Don't pick the points. I'm just going to pick these and any other things I might have already drawn. And I'm going to say, okay. And you're going to see up they went and aligned 12 points. So our points went, oh, now we can take this and get rid of that. I don't need that anymore. And I've got that. See how they are close. Now, it didn't do any scaling, but it held 0.2, rotated into 0.7 as a direction, and that made these other things move the least amount. So you can see I've got a bad, possibly, some bad corners out here. I've got something that, of course, you saw what I did is I actually, physically moved those corners up there to represent maybe finding something in the field that was close, but not exactly correct. All right. So kind of a useful tool, at least from a mathematical standpoint, I would think. And then you can start to compare your, there's your rotated bearings and such, and see how they compare. Here's one, 31, 32, 16. So that works. One's for the inside, one's for the inside and outside. So that's those lines remain parallel. No, we don't. I have to re-annotate those perhaps to get those two for you. One of those is this bottom one down here is that bearing that's parallel to this one. Um, so the red lines were moved up, but the yellow lines are not. The red lines are moved up and not annotated, so the annotation goes with the yellow line. So anyway, you can use that to compare to see how much things have moved, to see if you've managed to find the best way to fit that deed back into your uh, the ground space that you're working in with your set of coordinates. You can go out there and stake things in the field. All right. There's another, a couple of other things in our deed tools. You can, or let's say we've got, this was the yellow one was the one that we tweaked a little bit. So that's going to be slightly different than the red one that we had. So we've got instead of us typing in the deeds, let's say we already had it drawn from some other previous work, and go to our deed tools and say polyline to a deed file. Well, and again, if we choose this deed processing example, it's an existing file. We say open. I think this is going to allow me to do this, to append it. Deed name, and this is going to be, we're going to call this one Smith by survey. And I think it just overwrote it. I don't think it, let's take a look. Process the deed file. Nope, it added to it. Okay, so there's that one. There's that one that we did by the deed entry. And now we look at this one and we see that it's got, instead of 50 and 185, it's got 50 and then 184.34, 51.76, 185. Right. So it did append that. So if you have a bunch of deeds that are drawn, you didn't type them in, maybe they came in from tax parcel map, whatever source they might have been, you can then turn those into lots in a deed file. And then when you work with that, it's just a nice little way of tracking all that information and keeping it in one spot. And you don't have to worry about whether it's in the drawing or not. Okay. Questions on any of that? Everybody good and grab that? Okay. And then now, some coordinate geometry, as you've seen, we've done some inversing, we did some traverses and side shots, some different things that we did yesterday with the command line tools. And we had it generate a raw file so we could go back and make edits and do things to it. But there's a couple of things here. And here's where I did this note. We talked about this in the configuration under survey where we said show occupied point and backside point on the status line at the bottom of the screen. As far as I could tell, at least in earlier days, that only worked on the AutoCAD version, not the IntelliCAD version. I'm not sure if that is still the case. I've got that turned on that way. Let me see if I go from, say, 1 to 4. If I inverse 1 to 4. All right, yeah, see, I'm not seeing it. It would be down here at this stripe on the bottom. So I don't see that. Well, what about here? That's interesting. It thinks there's an external reference. Well, let's do that. So yeah, so you would normally see that stuff show up down here on the status bar in the AutoCAD version. It doesn't have any effect here in the IntelliCAD version, but again, it's nothing that we really need to worry about. But now a couple of the other things that we have is there's and this just gave you an idea of how to do draw locate, etc. So set to the existing fortified at kogo.crd. All right, so let's make a new file. And we'll call it Kogo example. And we'll say put that back down to 20. Say next. And as it comes up, I'm going to use the existing coordinate file. And I'm going to hit my set button and I'm going to find Kogo CRT. I've got 4 points in it. All right, pretty huge file. Right. And then next, I've set my points. I haven't drawn them yet. I'm going to draw locate points. And actually, I'm going to, even before I do that, I'll go ahead and do this so I don't have to later. Text styles. I'm going to create PTXT. But not, I don't want to rename. Okay, PTXT. Calibri light. All right. So now I'm going to draw locate points. Draw all. There they are. It's 1, 2, 3, and 4. So it just gives us some points to start with. And I think your example in here said you're going to choose inverse and see how it's going to Create the occupied and the backside pointer set. As you inverse between pairs, you can keep moving up to the different ones, asking for the occupied point, etc. And the previous as the backside. Very much the same as the traverse command. Okay? And you can try those different commands if you're not familiar with them. If you're not also familiar with Visual Kogo, that's a nice little tool, perhaps. And if you do that, and it doesn't matter what, I'm going to go ahead and set my occupied point as point number 1. So it's going to bring up a little dockable tool here. And I see that I've got occupied point 1. My backside point is set from the last time I used it as 507. I'm not going to use 507. Let's say my backside would be point number 2. You can just type it. You can pick it from this list, or you can pick it from the screen. So that was point number 3. All right, so I'm going to set it 1, backside 3. That's now what it is. And it computes some different stuff. I can set in an HI and set an HR if I want to do it. And now you can choose these up here: occupied point, enter and assign a coordinate value, inverse, traverse, side shot, distance, distance intersections, bearing, bearing intersections, and bearing distance intersections. Some different settings. If I hit the settings button, you can turn sound on and off, prompt for bearing, azimuth rotations, angle modes, that sort of stuff. All right. So let's do a traverse, or let's do a just a side shot. We're going to compare a couple of points here. So I'm going to choose a side shot. We've set our points, and I see up here at the top it says OC1 BS 507. Well, that wasn't right. Occupied 1, 2. Oh, I didn't hit accept. I had to hit accept to, let's say I had 3. And if I accept that, okay, now 1 looking at 3, and then I'm going to do a side shot. All right, so occupied point 1, backside 3, I've got an HI of 0, and you set in HIs and HRs and all of that. So I'm going to set a new point here. I'm going to start these with 501. And let's just do an angle right of, say, 90 degrees. And you got your choices of all those different. Zenith angle will be 0, and vertical angle, zenith angle would be 90, sorry. Well, let's change that to vertical angle so I can just type that 0. And the slope distance, or we'll just go to a horizontal distance of, say, 50 feet. And description here, we'll just call it SS for a side shot. You can use a code, look up a code table, and you can draw with the finish, all that kind of stuff. Create a point, yes or no. Draw a line to it, yes or no, etc. If you preview it, shows you where it's going to be. We like it, we say store. Okay, so this is much like being in the field with a data collector, right? So now I'm still sitting on 1, backsighting 3, waiting for my next side shot. Well, let's set this one at an angle right of, say, 135 at, well, we'll keep it 50 feet. Another side shot. Create the point, preview. It's going to go over to there. You saw it. Let's preview it again so we can see it. There it is, and then store it. Okay, so we've now used that to create those points. Now, what else we do besides just setting points? If we do traversing, it's much like we saw in the example yesterday on the command line. It just moves you up and keeps, you can draw the lines, yes or no, and do those different kinds of things. If we do, let's do a new setup, 2 looking at 3. So we do an occupied point. I'll pick point number 2. And it's looking at 3 already, so that's good. I'll accept that. Okay. So now let's do another side shot. 2's looking at 3. 503, rod height, etc. We're gonna go just a simple thing, 90 degrees at 50 feet away. We'll be there. We'll store that. And now we're still looking at 3. Let's go angle right. Let's go another 135 degrees. And the distance of this time we can calculate. Okay. We hit our calculate button and you can do some calculations, or you can say set by points. I want to go to the same distance as it is from point 1 up here to 501, for instance. Whatever that distance is, turns out it was 50 feet. Let's try a different one, set by points. Let's go from 1 to 4. So that's 104.14 feet. There we go. We'll return. And now we will preview that location and we will store that. Right? So, and I can exit that. Now that might be an easier way because you get to see things visually as to how they're going to work. Let's take another quick example up here. Let's go back to let's do some let's do an intersections. Let's do a bearing intersect. And so we're going to read our prompts pretty carefully. We're going to say enter to use the preview point or select the first base point. So I'm going to, let's see what my options might be. Prompt for angle method, prompt for offset. Okay. So pick a point and point number. Let's say point number 1 is my base. Now, how do I want to define that first angle? And I can use a drawn line in the drawing. I can use points. So I'm going to say, I want to find the intersection of the bearing from point 1 to point 4. So I'm going to define that by points. So P for points. So 1 to 4. That's my first bearing. Okay, now where's my second point? I'm going to do from point 502. And the bearing I'm going to use for that is also by points from 502 to 503. And that's the point that it would compute with that bearing intersection. Okay, you give it an elevation, etc., or just accept the 0. And this was a BB INT. Bearing INT as a description. Okay. So that's a way to project those 2 points out there back onto that main baseline. That's how it's done there. If we did another, let's do a distance. And this time you're going to see we got some possible no answers or possible double answers. So if I start here at 1, and the distance I want to look for is, say, 75 feet away. So it's going to be a circle about like this. And if I start at 505 as my second point, and I want to go, oh, let's say 65 feet away. And use the geodetic distance. No, we're just taking grid distance. Now, here's the possibility. It could either be at A, which is 50 feet away from 1 and 65 feet away from 505, but so is B. Okay. Now, how would we do this in a CAD system? Typically, is we would draw circles of the radius that we're looking for centered around each of those points, and then find where the circles meet and choose the point we want. Okay. But it says for me to simply pick near the solution or type A or B. So if I just click on this side, it's going to grab that point, and I'm going to call that bearing, I'm sorry, not bearing, but distance, intersect, solution B. All right, so no elevation. Well, what did it bearing? So I must have missed something. DD dash INTB. There it is. Okay. So if we do that same effort in our visual COGO, and that was a distance, to say point number for one, so point one with a distance of 50. And point two was, what do we say, 505, and a distance of 65. And it's going to be, my next point is going to be a 507, and the description there is going to be a distance, intersect A. We'll get the A one. We'll preview, and it's going to find this one, but there's also, what's my other solution? I guess there's already a point over there. Let's change this value from 50 to 55 and put this one back down to, let's say 68. It's a little bit different. I'll preview that. So it pulls it out to here. Now, this is going to work slightly different here. We do have two solutions, but it's only going to show me the one. And it does this, if I recall from the help system, I think it does it as the nearest solution to a clockwise rotation. I don't recall. We'll look it up here in just a second. But if I change that, so one for 55, 505 to 68, let's reverse that and say 505, 68 to 55. We preview that. Yeah, that puts it over there. So it's a matter, it's not going to show me the A and B like you saw when we did it on the screen. It's based on it's based on a rotation based on something. We'll look that up here in just a second. So if I store, let's put that back as 1 to 55, 505 to 65. Actually, we'll call that back to 50 to 65. Review it's over there. We'll store that. Okay. So that is going to be governed by, let's just find out what it is. Go to the Carlson manual. In the survey module, the COGO menu, visual COGO. Let's find. So that's distance. Distance section are two base points along with the distances from each. Distance intersection point for the two possible solutions of intersection. The intersection clockwise from the first point is used. So when it says clockwise from the first point, I think that means, see, we had the first point in our setup was this point number 1 of 50 feet, point number 505 of 65. And it's clockwise, and you can't do something clockwise from a point because this point over here is equally clockwise if I do it this way versus if I do it over this way. But I think what it does is it takes the point and it assumes a line to the east, and then it swings that clockwise, and the first one it hits is the solution it would find. So 55 being the first point, a line to the east, and it swings it clockwise, it hits this point first before it hits this point, or actually wherever that point is. Oh, it's up here, 506, yeah. So with the straight around it, but well, actually, no, that looks like it's wow, I sure do not find it. Let me see here. If I choose 50 foot here, and a 65 foot here. Okay, so you saw it on the on-screen prompts. It showed you this point and this point. Looks like we didn't store. Must have used a different number because it chose this instead of this. So 65 hits both of those. 50s hits this. Yeah, regardless, I didn't see. I didn't store the point there, so I don't see it. But I'm again. So if this went out to a east pointing line and you rotate that clockwise, it would have hit this point over here first. Whereas this one's east pointing and it swings it around, it would have hit this point over here first. So I think that's what it means when it says it uses that clockwise from the point, which is not really something that makes sense. It needs to be clockwise from some linear object, not from a point. You can't go clockwise from a point because it could have been either one, depending on which direction you go. All right. So that's just one of the limitations that you can find with that visual Kogo, but there's some other things about it that make it pretty appealing, I think. You can sort of see some of the tools, but once you get used to the tools and the things that you type, you're going to be able to pick those up pretty quickly just by using these keyboard commands as part of this to calculate your points. Okay. So there's a couple of other little things that tie into that. Let's say I'm going to draw, let's say I want to draw a line or a polyline. Let's just draw a 2D polyline. We'll take the defaults, and I want to go from point number 3 to, I want to go to a point that is at the 35 distance intersection from 2 to 3. So I could, you know, set the point to be, I could set the intersection point first and then draw over to it. Or if I just want to sort of use that as a point. Now, this is what is going to be called these point snaps over here. I don't see my toolbar being out. Hold on a second. Let's go close. It's my edit menu. All right. Back this up and get that toolbar turned on. If I go to settings, toolbar, setup, I want to choose my point. Transparent point. Man, that's what I want right there. All right, here they are. I normally have those docked over here on the side. But I'm going to float this out here so you can see how these work, and then we'll dock it. So if I draw a 2D polyline, and I go from point number 3, and I want to go to the location that is the intersection of a, say, a distance intersection here. Now I can choose a given point. I can choose a 3D point. I can choose a station and offset. I can choose a PI, or the projected intersection. I can go tangent. I can choose a centroid to a shape, what they call a geometric center, which is now a standard CAD snap. Didn't used to be. There's my angle distance, bearing, bearing distance, and my distance. So if I say the distance, it now takes me temporarily here, and it says pick a point or a point number for the first base point. So I'm going to say from point number 2 at 35 feet. The second point will be 503 at also 35 feet. Now, there's my solutions. I see them sitting there. You just pick near the solution that you want, or type A or B. So I'll pick up here, and now it's found that point, but it didn't calculate a point at that intersection. It just found it for me and let me use it. Okay. Same thing as if I go from, let's say we'll continue that line. And we're going to go to a point that is see here, we're going to go to a bearing, angle, distance, a bearing intersection. So if I go from 503, the first angle by, let's just go an azimuth of 0, so a due north. And now my second point is going to be, let's say, the point that I had. And I'm going to go by azimuth, and I'm going to go 90 degrees. So that line went straight across, and it hit the line that would have been here if I had a vertical line from that point number 503. Okay. So you can see how you can use these, even it's not necessarily a COGO command. I don't have to calculate a point. I can use these commands here to generate the point, and even certain things like station and offset. If I know that I need to go, well, what is distance here? Let's just measure here to here is 83 feet. So if I go to, I'm going to draw a line from, I'll say here to a point that's 50 feet down this line, but 25 feet, or let's say 10 feet off to the left. So if I go to a station and offset, I'm going to choose, first of all, choose a centerline file or a segment. I'm going to choose a segment. And now I get a little marker up, and you see I'm now locked onto that. But you see it runs out when it's off that segment. Notice my numbers are going to change, so I'm going to now type. So pick a point on the center line or enter a station. So if I entered 50, and then my offset, negative for the left offset, positive for the right, I'm going to say negative 10. So there is, I started out here in space, and I went to a point that's 50 feet down this line and 10 feet off. Okay. Now, Can you do that other way? Certainly you can. You can take this line, offset it 10 feet, just do a standard 10-foot offset. So it goes from here to here. And then you could have drawn this line here, say from this end to this end. And now I no longer need this. And you could offset that one 50 feet. And then drawn from up here down to that point exactly. And then get rid of these temporary graphics that you've drawn to help you get there. So hopefully you get a sense of the power of some of these tools and how you can use those. And this again are those transparent point commands. That's what they're called. Meaning that you can run them transparently inside another command. Any other command that asks for a point, you can go over there and choose those as a means of calculating those points that you want to create. Okay? Questions on any of that? All right, we're doing well. We're ready to actually come in for our mid-afternoon break, and then we'll finish up with LotNet processing and maybe talk about some other options. We will take a look at as much time as we have that we can at some of the layout information on how to generate these plats, how to come up with finished plats. I think, Cameron, that's going to be something that's going to land on your desk from what we talked about the first day. So we'll see how much of that we can get covered. All right. So first of all, any questions? Anybody have any issues that are
No questions here.
I think we're good.
good? All righty. I will also record. So what we have here, I'm going to first of all, before we switch into that, I want to let everybody know a couple of resources on some additional learning. But try when you're working on this and picking some of this stuff up on your own, of course, those two files on the field to finish, this really gets into some good deep examples of some of those extra tools that you can do with that. And you'll find, we barely scratched the surface. We don't have time to do much more than that. But I would encourage you to go through those examples from that. Okay, that's one place. Another thing too, oh, excuse me, I'm so sorry. Another place to check is the Carlson help system under help Carlson manual, whereas you've got these things by the different introductory stuff, the general commands, there's file edit, view, draw, inquiry, settings, points, and of course help. And then the specific modules. There's the survey module, which all of you folks may have, the civil module. So all of these different tools, but there's something beyond just that I wanted to show you about. And it's down here in this section called tutorials. Okay. So there are some tutorials here. There's some CAD basics, and that shows you how to get started, how to load up and do what the different interface parts of the screen are. Now, you guys may all well be familiar with that, how to set the properties, etc. So that's a nice one. Entering a deed. Okay, now we did that one already. And this is the drawing setup screen here. And then it's where they, typed in the information about the deed itself. Okay. And then they show you a couple of other things here with this title block that you can create a title block and fill that information out. So this is getting in toward doing some of those plots that you were talking about for Cameron. Putting in title block information. Now this is sort of not the way we do this anymore. It certainly works, but this is back before we had paper space and model space, and we do things in paper space pretty much all the time, but the concepts are all the same. So it's a nice little exercise to work through when you get a chance. It's to, put in your surveyor certification, your title block information, the bar scale, your north arrow, and how to basically come up with the elements of a drawing. Making a plat. Now this one was, again, it's going to sort of focus on that. Here's a bunch of points. See what its main focus is. I can tell from the shape of this that comes from that field to finish data set that we used. There's the fence along the back line, the property line, the edge of the road, and the arc. There's that four-sided building for the shed. Okay, there's the driveway. There we go. Let's see. And they're showing you how basically you would do all of this stuff after you've got points in the drawing. This is not using field to finish. Okay, this is how you would normally do that. You would put in easement for your power line that goes across the property, that sort of thing. Setting your trees and how to create an inset, a blow up of a part of the structure. Okay, so all of the different tools that you would use to draw those, and then compute your, say, the corner offsets from the nearest property lines. Okay, put your joiner information down. So it's a really nice way of how to go about generating all of the required elements for a plat. Okay, much like you did the other little example. And drawing a legend, for instance, it can read the drawing, look at the symbols you've used, and create a legend for you. We'll get it. We'll go through that one here in a minute. So again, how this all comes together. So if you go through this and you see that, maybe they're putting this stuff together in model space. And again, you can plot out a model space. There's nothing wrong with that, but we typically do it in paper space as a separate item. And these things that you see down here are not generally drawn in the actual CAD model, but in the layout tab, the paper space part. But the whole thing, the concepts still apply exactly what you're doing. But the nice thing that this does for you here is shows you these commands like how to do building offsets, how to show building dimensions. I'm trying to get a picture, bigger picture so you can see that. There you go. So you see how it's labeled the actual building dimensions around the building as well as the offsets to the corners. So those are all the things that would be really helpful to getting your finished plats prepared. Okay. Now, the next one below that is called field to finish for faster drafting. And this is essentially the exercise we went through. Okay, so there's our map, and then they're taking it a little further, even beyond what we did, and putting it into a title block with a legend and a bar scale and a north arrow. So, and there's your contour lines that were drawn as part of that as well. Okay. Intersections, subdivisions, you see there's various, and this is some of the older sort of one-off commands that we don't really do a lot of much anymore now that we have LotNet to generate a lot of this stuff automatically. But again, the whole concept was there before. It worked on a single or small lot basis. Then it will also work on a big lot basis. So we will, we're going to take a look at that kind of stuff. But each of these different, you see the topics here on the left out of my table of contents, and I'm getting, you know, information. I can see the information over here and the steps that I used to go through. Some of them won't be any sense. Some of them have road rehab or hydrology and watershed analysis, and you're not going to necessarily use those. But these others, there's your contouring, digital terrain modeling, design, et cetera, et cetera. Okay, so some good information there, even though some of it's old. There is another set of resources, and that's this if you go to Carlson's website, and there's a a whole thing. If we go to the quick links over here on the side, there are some movies. For instance, I go to that, and it's going to kick you out into their YouTube channel. And there's all kinds of things here, and you can search for survey stuff. But I mean, this is everything: mining, precision 3D, hydrology. And there's one I just saw: subdivision layout with LotNet. Drone photos, converting to CAD with photo capture. Tree and pipe features and other field to finish, for instance, and it's just going to step you right through. We're going to watch this. It's 27 minutes long, but you see how he's putting in a code for a tree, and that was very much some of the stuff that we went through. And but they're really, really good and a great little refresher thing for you. So do not lose track of those things as resources. Also, if you go out to back to the start page, you've also got some of those same resources: Carlson support, Carlson Academy, that's InSoft is part of that. You have knowledge base, tip of the day. So you've got all kinds of these different options to sort of help learn the software. Okay. So let's go to the start page now, and we're going to open a file instead of start with a new one. And we're going to navigate to our survey class data set, and we're going to find this LotNet. Oh, goodness, we got the LotNet file on it. We had, oh, sorry, not LotNet final. LotNet final is what, that's the Finnish version. We want this Clearwater Oaks. Well, that's the name of our subdivision. And we have the starting point for our Clearwater Oaks subdivision. Now, there's a couple of things. This is all going to use LotNet processing. And LotNet, that's what they call Lot Design Network. And you can see that it's over here on this area layout menu. And it's got all of these lot network commands are right here in this section. But there's also a couple of toolbars that are going to hold those commands, because there's all kinds of sub commands with it. And the toolbars are very nicely arranged, and I'll show you where these are and how to bring them out and use them. You've also got some things down here, lot file utilities, lot file manager, create lots. And these are sort of the older version. It's not lot network. It's just how we did lots before. They're sort of single one-off kind of things. Still very effective, but lot network is what takes an entire subdivision and just really goes through a lot of different options and automation, just like field to finish does. And by the way, too, if you all are surveyors and you know if you've got a particular you need to repartition something or change the area. On that area layout, you've got some of these like adjustments. You've heard of hinged areas, sliding side areas, and those kind of things where you can adjust the size of a parcel to have a target amount of area of ground. So those are things that are there. You've also got some of these layouts where those offsets and intersections, that's sort of that old way of doing those intersection road designs again that you saw in the tutorial. And then some parking utilities, and these are kind of new, and they're easy to forget that are over here, but this will let you design parking lots and lay them out, very efficiently. And look at some of the YouTube videos on that, and it's like you give the starting point, and then you tell it how many spaces down this alignment. And, you can lay out a whole mall parking lot in about 10 minutes with parking islands and spaces and buffers, et cetera, et cetera. Okay, so there's some really good tools there. There's also one in field to finish. There's a code for parking. I wanted to show you that real quick. I'm not going to run the command. I'm just going to show you in the help system. And it keeps, there we go. Survey. Finish. Let's search for park. Land parking along an alignment. Now this is the actual parking network. All right, so there's, for instance, like if you put in a point and then you tell it, how many points you want to bring in. I'm not sure this is part of civil. I mean, I'm not sure that this is part of survey. Area layout, parking utilities. Yeah, parking network. Okay, so there it is. So really, another one of those network tools that just really helps you lay out these parking lots really quickly. But I wanted to look under the field to finish. Let's see if we find it as a code. Not there. Yeah. Oh, here it is. Drop field to finish. That's all. And let's see if we can find that code. It should be highlighted. It's such a huge, there we go, parking. So what would you do in field to finish when you're out in the field? Let's say you needed to survey this parking bay but you didn't want to get all the different stripes and all that kind of stuff. But this code will actually draw the lines for you when you process it, and you give it these points. I've got a parking, I've got a PP, that's my parking point, and I say parking 8, means I've got 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8. So there's my corner, there's one corner, I give the upper corner, and then I give the outer corner. So I'm sitting at the radius, or not, the corner. And you see that this parking is at an angle because that point up there is set at an angle. If it were, 90 degrees, it would be probably right in here. And you sit there, and so it just does that and then divides that gap and puts the stripe is as long as it would be to go up to get the end of this one. So we're going to measure that as a prototype stripe. It's going to replicate that down to give you the number of spaces, and that goes after the code called parking 8. And that's, again, one of those special codes, just like rectangle, close, etc. There's the curb ramp. And so that was what I neglected to show you that. So let's take a step through this and see what happens with LotNet. Okay. So if you look here, we've got some settings. We need to pick a boundary. We have to have a closed boundary, and we need to, mark the roads that are going to be part of. So we need center lines. So we can establish rights of way widths and parcels off of the roadways through these as well. But all of those commands are reachable through these, or we can also choose them from our toolbars. And the toolbars are, go to settings, toolbar, setup, and we're going to scroll down here until we see LotNet. So lot network right there, and I don't think it's layouts. Let's see if it's the one is right here, and that's called lot network. Might just be the one. So did I make another one? Yeah. Yeah, it's SiteNet that uses the double, so we're good to go. So lot network, and these are going to be a little really helpful in that we typically do this from left to right as things progressed to be able to set this stuff up. So the first thing we're going to need to do is we will need a closed boundary. And so I look at that, I select that outermost line. I look in the properties over here and I see whether or not it is closed, and it is yes. And even if it looks visually like it is closed, it needs to be mathematically closed. So make sure that that's set to yes. If it's not, go ahead and turn it to yes. Yeah. It's fine. Okay, so now the first thing to do is the leftmost button is set up some settings. So we're going to click that, and we're going to tell it the lot network file that we want to process. Well, we don't have one yet, so we'll make a new one and we'll call it Clearwater Oaks. We'll open that. Okay. Now, filling this stuff out, we again can select a particular different file, lot network file. A road network, right now it says none. So let's go ahead and choose select, and we're going to make a road network file, again, a new one. And we're going to call it, I'm just going to call it CW Oaks for Clearwater Oaks. Okay. And our starting lot name will be lot number 1. Our lot area tolerance, so if we are computing areas of non-enclosed spaces, we can go up to, say, 4/1000. So basically, they're all going to be close, so it won't matter anyway. And the edge direction is going to be away from or toward the frontage. And that's just the direction that it draws the lot edges. Really doesn't matter. And then this output lot file, if you choose that, it will make a lot manager file, which is separate from the lot network. It's much like that deed file where it would hold all of those individual deeds and you can work on them. It's really not necessary. To have it, you can, one of the things it's useful for is to, if you're going to go out and stake the subdivision out in the field, you can take that file with you and it will generate all this stuff on the fly for you. You don't have to gather it all up. Automatic label update, yeah, we'll let it do that. So if you'll match these settings, and that should be sufficient. Now we've got up here, these are some layers. It's going to put the lot lines and the building placement settings. Right now they're set to default. And if you select a particular file, or let's edit that file and see what the building placements are, I'm going to say put buildings. I need a front setback of 20 feet, side setback of 10, rear setback of 10, different layers, etc. You can draw the setback lines, you can draw the building pads, and you can draw building symbols if you had them as a separate type of block, this block that you would do here. So you can draw the pads, and then you can draw the actual building itself. Where there's a pad width, etc. And you can draw driveways, okay? Left and right offsets, etc. We're not going to get into all that. It takes a little bit of time to drag through the processing, so we'll leave it there and say okay. So now, well, as a matter of fact, I think I'll draw the setbacks, but I'm not going to draw the building pads or symbols right now. You can always come back and reprocess later, but that would be this. See those where the building pads are shown, and it's just, it takes up quite a bit of room in there. Let's use this sort of minimal to get through it. So that was our building setup. We've set our file, we've set this, we've set our default layers and the things we want to label. Our label lines and arcs. I'm going to edit these settings. So if I edit the lines and curve labeling, this is the auto annotate defaults. And there I'm going to put an angle over a distance based on this row number above and below, and whether I'm going to use a table. So I'm going to say, yes, use a table by scalar, and that scalar is going to be, let's make it a little bigger than that. Let's make it 0.75 feet or 0.75 inches is scalar. So if it's 3/4 of an inch is all of the length that you have to be able to put the bearing in distance, I'm going to say put a table reference and not try to cram it in there and hog up the drawing. Okay. I'm going to also look at the arcs tab, and I'm going to define my arc length, radius. There's a chord. I'm not going to show that as my delta. We'll show that, and I'm going to come down here and check to use the symbol for the delta. And then I'm going to, same thing with the curve table. if I use a curve table, why is it not? Oh, stack labels. But use, and that's to stack them up by the curve. Or I can use a curve table by scalar. And again, if it's going to be less than, say, an inch, put it in a table. And that should be all I need to worry about with that one. Labeling the areas. If I edit that, I've got square feet and acres is all I'm going to use. Square feet is going to be first. I double click that and I see what I'm going to label here. And I'm going to put my precision to the nearest square foot, not to any decimal places. And my acreage, I'm going to put to the 4th decimal place. And I'm going to use the plus minus symbol as a suffix. And I'm going to also use this space AC. So that's so many acres, and I'm using acreage. Okay. Now, the reason I do my square feet to the nearest square foot, nearest 1 square foot, and my acreage to the nearest 10,000th of an acre has to do with significant figures, because there are 43,560 square feet in an acre. That's on an order of magnitude of tens of thousands. So it's in the 10,000th position of the acre number. Is that a change in that digit position would reflect a change in the single foot digits position in square feet. Likewise, too, it takes a change up in the single foot distance, and it would trickle a change to the 4th decimal place in the acreage. Right, so it's just a way to match. Sometimes, I've got a client that lives in a municipality that they want to see square feet to the nearest 10th of a square foot, but they want to see acreage only to the nearest 3 decimal places. Well, it doesn't make any sense from a mathematics standpoint, but that's their regulations and he has to comply by them. So you've got control over that as well. All right. So that's good for those. We'll say, okay, label lines, automatic label. Okay, we're good to go with that. So we've got some settings done. Now, the next step is to set the boundary, because none of this will work until you have certain things in place. So I'm going to set the boundary, and it says simply select the boundary polyline. Well, there it happens to be. I've selected that outside boundary. Now, my road network is, I'm going to choose my road network, and it's going to come over here. There's the name I gave it. I have nothing in it yet. So I need to build the roads. Okay. And I've got polylines that represent those center line alignments. So I'm going to come here and first look at some settings. And again, these are just something you'll set once and forget. But I'm going to use, what my road transition default. So when my roads come into an intersection, what's the radius that I want on the edge of pavement? In this case, it's going to be at 25 feet. Do I want to reprocess every time I change something in these polyline layouts? You can either be off or prompt you for it or do it automatically. The right-of-way snap tolerance, 5 feet, create lots. So this is when I choose my settings to create my lots. This is where I set up how LotNet is going to generate lots for me based on the road alignments within this closing boundary, this enclosing boundary. So now my target lot area, in this case, I've got a 10,000 square foot. You can choose it to be by acre, by square feet, and a particular minimum frontage. Use the setback line for the minimum frontage. Otherwise, it would be measured at the right-of-way line. Depends on your municipality or your locality as to what they require. A minimum lot depth, a maximum depth, a minimum back distance, and that's basically a frontage. This is a backage, if you will. It's the width across the back. We're going to let it go to 0 if it needs to, so it could have some pie-shaped lots. An interior and a back reducing offset, and then our edge method is how do we want to draw our lot edges? We want typically to be perpendicular to the right of way or perpendicular to the back line, in which case it would be for those perimeter lots, it would be the bounding property, or it could be at a specific angle relative to the center line of the road. So I'm going to choose these as being perpendicular to the right of way. And when I do these 10,000 square foot lots, I'll get the most in that I can get. I'm going to have a particular remainder, perhaps. How do I want to handle that? You can create a separate end lot. So maybe you're going to have, some green space requirements, or you just want to set aside a little playground for the kiddies, or you can apply it equally to all lots. So add up that to each of the lots, or simply add it to the last lot. Or you can create it at the back, again, like a green space strip along the boundary of this back lot edge. Checking the building placement is an option. I'll just show you what those are. We're not going to do it, but that lets you make sure that those building footprints are going to fit within these setbacks. Okay, we're not going to do that processing right now. And so that is going to create our lots for us. And that is basically the settings that we need for that. We'll say, okay, so now we've got it. Let's create our network of roads. And if any of you are in, Jason, are you all using Carlson Civil?
I'm using
Like,
Carlson
are you
Suite.
doing your road design using road network in the civil module?
Our civil department uses civil.
You were muted if you said something. I didn't hear it. Still not able to hear it. Let's see. Whoops. Wrong,
You got me?
wrong button.
Hey, Dave.
There we go. Now, Jason, go ahead.
What was the question?
I
Are
said,
we using
yeah,
civil?
are you using Carlson Civil module to do your road? Are you doing road design?
No, I just leave that to our civil engineering department.
Okay, but are they using Carlson, or do they
No,
use
they're not using Carlson. They're using civil though.
Civil 3D or something like
Yep.
that? Okay. All right. So I was going to say this lot network roads, this is a road network, and it is very similar to, it's not exactly the same interface, but it is the exact same lot network that works with civil, with the civil module. So if you were doing that, it's a way to sort of share the wealth. But in any case, we have to build a network of roads so the lot layout knows how to process this. So we've got roads, intersections, and cul-de-sacs, and we're going to come up here now to our plus button. We're going to add a road. So we're going to add a road, and we're going to select the center line by picking a polyline. So I'm going to screen pick a polyline. And I'm going to pick this main one that's down here at the bottom and turns and runs to the north over on the west edge. I'm going to pick that, and it says, well, you don't have a centerline file associated with that polyline. So I'm going to assign one to it. So I'm going to call that, be in my area here, and I'm going to call this one Clearwater Drive. And it says, warning, the center line is outside the area covered by the existing surface. Okay, so I don't have an existing surface. And that's why this is just a warning, because this whole process can grade the lots and grade the roads based on the profiles and all that. So we're not going to use a targeted terrain model, but we have the option to do so if we would like. So I'm going to say, okay. And here now is what we're going to see. We've got a center line called Clearwater Drive. If I hit that edit button, Clearwater, the coordinate file would be, we don't have one open yet, so we'll just call it new, say open. And there's the alignment. You can see it's just exactly like we saw yesterday, and it matches this. And there's that curve, there's that line, the curve. So it's just like it's exactly the same editor, the centerline editor. Now let's look at our right-of-way offsets. So we need to make a right-of-way file. We're just going to call this one a new one, and we'll just call it CW Oaks RW. And we're going to choose the edit button for it, and we're going to say, okay, let's define this. So we've got the right-of-way layer. We've got the left and right offset of our road. Well, let's see, we're going to want, so we have 12-foot lanes, some shoulders, a utility corridor maybe. So let's make 25 each side to define its simple 50-foot right-of-way. So that's now going to define that. We'll say okay. And that now has defined Clearwater Drive. So let's add the remaining drives. So I'm going to add a road by screen pick polyline. I will pick this guy up here. I will assign the centerline file, and instead of Clearwater Drive, this is going to be, I don't care, Riverview Boulevard. Again, it's outside the area covered by the existing surface, no problem. The same right-of-way, we'll just call it that same deal there, so everything's good to go. And now the last remaining one is a road, screen pick, and that's this center line. And that's going to be, we're going to call it Bridge Street. Again, the warning. All right, so there's all my roads are defined, and notice what's happened over here is it identifies these intersections. Okay, now each one of these things, if you double click on any one of them, you're going to get the editing tool. So if I look at this intersection here, I double click it, I've got, I'm telling it on this intersection, which is my primary road, that's this Clearwater Drive. And I've got these right-of-way radius values for the front left and back, or front right and back right kind of stuff. Any output files if I want to generate for the right-of-way line, I'm not going to bother with any of that. So that's how those are going to work. Got each of those different ones so you can have different values. And now I'm going to finally add a cul-de-sac at the end. And it's going to be at the end of Clearwater Drive. Either the start or the end. So this will go to the end, and we'll just take it as a standard cul-de-sac. And the right-of-way radius, if I've got to say a 60-foot pavement radius, so that's, And if I did that to 25, so let's put that out to 80, I think would be a good number. And now my fillet radius for my right of way is I'm going to call those fillets. Let's just make them 35 feet. And it might be too big. Let's just say, let's make them 20 feet. None of these offsets and stuff. We'll just work with this and say, okay. All right, so now we've got it. We're going to save this network file. And right over here is a process tool. So when I process this, see what it does? It's going to compute that right of way and display it there as it's creating it. And then it's going to create the lots. It's still working. And now read the prompts. It says, give me a starting point for a curve table. Well, I'm going to go off here to the right, and I'm going to click my curve table there. And I want the starting point for my line table. And I'll come down here, put my line table here. I'll decide to put them in a different place later, maybe. Okay, so there's all of those little segments of lines that don't fit are down there below on the left, and all the curves that don't fit are there on the right. And it's just about ready to finish here. Okay, so there's our curve or our line table. It's our curve table, and you can see them labeled in here. You know, see 25, 26, 27, 24, et cetera, et cetera. I've got these are on my setback layers. Let's change that layer. Let's see here, setback. And it's going to be a small dash here. And let's say P line is on. That's good. I'm going to set my OT scale down to 0.5 just to make them tighter. There we go. So it's going to draw those, and you can see all of my targeted areas are coming at 10,000 square feet. And I've got one here at 17,093 because it can't fit. Here's sort of a skinny one, so we're going to do some adjustments accordingly. And then here is this last one that the remainder tacked onto the end of that one. Same thing on this block up here, 12,950, because we couldn't get another 10,000 square foot one in there. You can see how it's automatically created this stuff based on these values. Now I've got this little bitty thing back here. I would probably not do something like that. I would really just kind of run this out to the corner and let those lots, they are already bigger than 10,000 square feet. So here's the adjustments that you can do. You can add and subtract lot edges, move them, re-subdivide an area. So let's say if I wanted to, remove, say, this lot and then re-subdivide that into two separate. So I'm going to come here and remove a lot edge. I'll click that, and I'm going to click this one right here. So it gets rid of that lot edge. Come on. So it does take a little bit of processing, but it doesn't take a month to design your subdivision either. Yours may be going much faster. I'm not sure how yours is doing because I'm having mine set to check for label overlaps as well. So so I removed that, and that's actually was able to fit a 20,000 square foot lot in there. So if I've got 20,000 here and 10,000 here, I could slide this line down to where my target is like 15,000 on each side. Or I could add a lot edge, say from here down to here, to where one of the lots fronts on this street and then this lot would front on that street. But that doesn't give you much of a depth. So let's do that sliding the sliding side or hinge side. So if we do if we want to keep this line perpendicular to the right of way, let's do a sliding side area. So pick inside the line of the lot to adjust. I'm going to adjust this lot. So I'll pick there. Select the edge to adjust will be this edge. And now my target area, I'm going to say 15,000 square feet. And you can see it's now going to split that original 10 and 20 into two 15,000 square foot lines. Okay. So that's just a process. Excuse me. You can go through and look at the results of these things, maybe adjust the size of the cul-de-sac, maybe reset some labels. Like I don't like that particular font, and maybe I would put all of my curves in a curve table, because it's just a little awkward to have all that mess in there like that. There's some real, if you look at those, so there's real overlaps in here with these lot or the line labels, because it's generated all these little bitty segments down here, because it's, this is sort of the result of an offset of the center line, offset of this center line in this direction, and it's trying to come up with some individual pieces. So you could do some modification here to help things out. So if, let's say this line back here, I don't like that little dog leg in it. I just want to go from the corner to the corner. So if I do a remove lot edge point, so I'm going to choose that. I'm going to take that point out and take that point out to make it go straight from up here to down. And let me take one more out. So I'll go from that corner down to here. I'm done. I'll hit enter. And now it's going to readjust everything and redraw, recompute. So I would now need to take these and adjust those corners. So I would move in my well, I think really all I need to do there is just a simple trim and extend. So if I trim these, I don't think I don't get that. And then we will extend these. Okay? Some places do not like to have these little staggered offsets, so you could move this lot corner. There's a corner point, and then there's a corner point. So you might change that location. So if you're gonna change the lot edge, and then I add a lot edge, I'm gonna add a point, I'm gonna move the point. So if I take this lot edge and I move that point to here, for instance, then when it reprocesses, it's going to do that same thing and try to, meet all of my design criteria. Because I did that. Now up here, you saw where I took out those points in there, and you see I've still got all these little points in here that generate these little lines, those little line segments. So, you could do a little bit of cleanup, and I would clean this guy back. Okay. I could update the labels, and I could do renumber my lots. Let's look at my lot network inspector real quick. And as I hover the mouse, I'm not clicking anything. I'm just putting the mouse in these individual lots. And it's showing me what that information is about that. Okay. I'll hit enter to finish that up. And if I renumber the lots, I don't remember it, but I do want to set my labels. Update my lot network labels. Actually, what I need to do that is setting this. Starting lot is one. Select to label the areas. Oh, to put my lot number. Lot. Lot description, I think, is what I want. And not sure that that is the one. Should be lot name. For that label lines, I'm going to label settings, general label settings. Do my curves. So use curve table. My scalar. Say an inch and a half. So many around. Cul-de-sac and label lines that I think. That's good. Updates, logos. meant to change the text style on the curve label, but you get the idea. We can set that up. We could spend all day chasing down the little things. Yeah, there's their label. There's their lot numbers. That's what I was looking for. So now they took out these big arcs with labels for these smaller pieces out when I change that size. All of these things automatically update anytime I make changes to it. And if I move, say, this point, I've got the L49. That's that little short piece. If I go down in my line table, L49, that's just 8.5 feet. Well, that's not terrible, but you might want to make sure that goes straight to the corner. So you could simply move this point from there to there. And then it's going to recalculate. Now, when it recalculates this, it doesn't go through and make this 10,000 and this 10,000. It just pulls that line down. If you wanted to have that recalculate up there, then you would need to, to recalculate where that is, you would then need to decide, that if you wanted to adjust this area. So I've got 10,340, 10,350, 14,370. So I've got some length because it couldn't get, say, a 10,000 square foot lot in here all the way around the area and still meet things like frontage and setbacks and stuff along those lines. Okay. So now I've gotten rid of that L49 that was 8.5 feet. And there isn't, it's 2.45 feet. There's one that's here's one that's 0.67 feet, L43. That's, I would track down that one and find out where it is. It's probably one of these little things in here. Okay, but you get the idea of how you can use this to generate your subdivision stuff very, very quickly. You could even, let's say we put in another road. Let's say I did, let's see. I'm going to draw a 2D polyline. Say okay. And I'm going to turn my snapping off, and I'm just going to say go from here to here, then to here. All right, I'm going to next match the properties of that to that. I will even isolate those layers, and I'm going to turn that into a centerline alignment. I'm going to go up to centerline and say polyline to centerline file. I'm going to call this one cross court. And there it is. And I will now put a little curve in there. I'm going to fit a curve. Let's make that a 35-foot radius and see what that does for us. Too tiny. Make it a 50-foot. It's better, I think. That was make it even bigger. A little bit more than that, say a 75 foot. There we go. I'll now save that and exit. And now I cross court. I'm going over here to my roads. I'm going to first thaw my layers back on, or restore my layers. I'm going to go and add a road this time using a centerline file, which was cross court. And it's okay. I now have, it's identified the roads, bridge, there's cross courts. We got the Clearwater Drive at the end of Riverview and the bridge, Riverview Bridge to cross court right there. And I'm going to add a couple of cul-de-sacs on to cross court at the end. I'll just take the same one. Let's make this not quite so large. Let's make that, say, a 60-foot radius and see what that's going to look like. I'll add another one on the start of cross court. Ooh, gotta get rid of. Oh, I've got to define this one. I think I've made it too big. So that's now good to go. And I'll save this, I'll process and watch as it goes and does its thing. Now, not ideal. You see, I hogged up some good usable land by trying to put a 50-foot right-of-way road in there. So it's not, something that I really would want to have done. There's no need to have done that, but you get the idea of what it's doing. It's recomputing those areas based on all of those parameters that you gave it. And if you recall, when we were looking at the settings, you could have it do things like drawing the buildings, drawing the building pads, drawing the building footprints. That's assuming that every building is exactly the same, which was not really good design. You could have it draw the driveways into each lot. Okay, so not anything. I'm going to actually come in here and remove cross court, and that then took out the intersection and the cul-de-sacs, and I'll reprocess that and let it go back through and do its thing again. And I'll ultimately need to go in there and manually erase that polyline that I created first time with create the street. Okay. And again, if you had your layers all set up with different line styles and colors and all of that, you would, see it produce things accordingly. And it's not finished yet. Is it? It's supposed to draw my setbacks. Let's see. now. So I've got in here, and then you would go back and make those same type of edits with removing these points. But look at this lot here. It's 47,673 square feet. Well, you could, if you've got an odd situation like that where the math just didn't work out exactly, one of the options up here too is to subdivide that area. So if I choose that, it says pick inside this area to subdivide. So I picked in there, and it wants to know, how do I want to do it? Well, I can prompt for each area, prompt for the frontage, or just do automatic using my 10,000 square foot target, 50 foot, same as I had before on the rest of it. I'll say, okay. And pick the end of the frontage for the starting lots. Let's say it's going to be here. And it will recompute those into those 10,000 square foot lots. Okay. Up here's one. Now I could split that in half, or I could, sell that for more money to, the guy that owns a car dealership in town, because he needs to have a bigger lot and he's on the corner of the street and everything else. All right, so hopefully you follow how this is, whereas it's not necessarily do what I'm thinking kind of automatic stuff. It at least will generate, take care of a lot of the work that we used to have to try to do individually. And then we'd have to label all this stuff and run all those different commands separately every single time. You could also, create this as a 10,000 square foot lot in here. And then whatever's left over, you could dedicate that, say, as a little parklet or something. So any number of ways to help you do that. There's that 10 and 15, so 25, you could split that in half. So still a couple of little edits that you got to wind up doing, but I think you should agree that it will save you a tremendous amount of time once you have those things set up and you're starting to play around with some options, okay? So I'm going to say save and exit my LotNet. I'm gonna put my LotNet stuff away here. I'll even turn off that toolbar. I'm not using that anymore, and then I could take that on the way toward making my subdivision plat. Now, here's a little trick I'll show you, and then we'll call it a day. When we typically draw parcels like this, you would normally put like little circles around for the lot corners, would you not? And yet I don't see any of those. I've got stuff, and I don't want to have to go through here and try to find, trying to find, well, there's a point there, there's a point there, and there's a point there. Those are all, and there's a point here. Those are all going to be property corners. Have those little circles, but I can't necessarily see them. See, I don't really see a point in here. I know there's one because I'm coming off an arc into a straight segment, but you can't be sure that you're not going to miss something. So I'm going to isolate the layer that the boundary and the lot lines are on. So that's my actual property. I would have taken out these little teeny tiny ones in here. So assume I did all that. I would also probably have, say, taken this out and just extend this down to the corner. In fact, we're going to go ahead and do that. We're not going to go to the processing effort of LotNet to recalculate all that stuff just yet, but we'll Nothing will be done. All right, so now, excuse me. So here's a way to put those little circles down where those points are gonna, where those block corners are gonna go, and even to be able to go stake them out in the field because you'll have all the points down. So if we do a on the Kogo menu, we're going to create points from entities. Okay, we're going to choose this circle as our symbol. In fact, we're going to not only choose that circle, but we're going to choose it a different category, points and wipeouts, which will be the circle, but it's going to block out whatever's sitting underneath it. So that'll work for us. And I'm going to start these at point 1001. And I'm going to call this P core for a property corner. And we will take the same description for all. I'm not going to label elevations. I'm not even, well, I'll use the point numbers. And I'm going to draw the points. No, I'm not going to draw the points. I'm just going to create the points. So I'm going to choose that and we'll say, okay, entities to process all of these things here, except I don't want radius points or midpoints. And I'm going to say, okay, I'm going to grab all of this. And it now has created 216 points and it avoided 4 duplicates. If I look at my points menu, and I list my points, there's, I start, looks like they're all P-core. That's the only points I generate. All right, so they're all there. Okay. Now I'm going to draw locate points. I got those points. I can go and stake those out. I can put them in my, survey, do my cut sheets or send them out to my data collector. But if I draw locate the points now, and I'm going to put these on a layer called P corner, let's call it prop corner. We got the symbol SPT4 with a wipeout that's good. We are going to set our symbol size. Let's make them just a little bit bigger than 08. We'll make it 0.1. And I will not draw the descriptions. I will not draw elevations, and I will not draw the point numbers. So it's just going to draw the symbols. I'm going to say draw all. And now I've got the wipeout frames. I'm going to turn off so you don't see them. And I will now take, see if I can isolate that point. There's a point. I will select similar and put them in the back. There we go. So now you can't see it. So there now are all the points. And again, like I said, I would have taken out these little nuisance lengths in there to do it. But I didn't have to go through and snap and put down a point symbol. It's all there. I can restore my layers. Everything's good to go. And of course, I would have fixed this setback back in here, and these numbers are no longer valid because I pulled this down here. But you get the idea. If I did it inside of LotNet, it would have fixed that calculation. Okay, and there's a little point. That's probably that 0.67 segment. So if I want to see what it is, if I inverse from there to. That's 0.977. What was the? Yeah, so, all right, so there's another one that's even tighter. And it's probably a situation like that. So, you would adjust, like here's, for instance, one. If I want to see what goes, if I only goes from here to there, that's a distance of 0.67, so that's pretty tight. Obviously, the better approach would be to adjust this lot line to be just go down there to the corner. So you're not, but he had to kick it out enough to meet, some of the requirements here, or it met the 10,000 here and stopped where it didn't need to go any further. So just little adjustments like that you can make. So it's not going to do, everything just magically, but it's going to save you a lot of time and effort. Okay. Yeah, take a look at those tutorials, especially Cameron on your end, those ones that are about making a plat, where it shows you how to use the things, the symbols, the line work, and all of that kind of stuff that is already in the drawing to generate legends. How you can set those things up to create those layouts. And, just the more you use it, the more you struggle with it, the more it's going to become part of your day-to-day operations. Okay. So anybody have any particular questions?
Nope, I'm good, Ken. I appreciate it. I gotta head out, so I appreciate everything.
All right, folks, I'm going to wish everybody a very merry, happy weekend, and be safe out there.
All right, thank you.
Appreciate it.
All right, guys, take care now.